Hello students, welcome to the class. So today is our day 15 of this JEE crash course, and here we will be covering the chapter Redox reactions. Okay, so we have covered the full part of equilibrium, both physical and ionic, and we will move to this new chapter which is Redox reactions. Now this chapter is quite small in length. There are only 2 to 3 points which are important in this chapter. We will discuss about that in the theory part, and then we will do some questions on it. Okay, so please join the class. We will begin our class in few minutes. This is disclaimer. Now, first of all, let us discuss the weight percentage of this chapter. That means how much percentage does it carry in our JEE exams. So from the previous experience, there is a 2.91 percentage of marks which comes from this redox chapter, and at least one question is asked in the JEE. The important part is that which questions are asked. So first of all, you will see that questions are asked from the oxidation number. Okay, so I've put most of the questions from the oxidation number part rather than from putting it from balancing redox reactions. Okay, so that is something which you will get through with the help of practice. But in the case of oxidation number, there are chances of making mistakes more, and it is easy to do also at the same time. So I will try to explain more questions on this oxidation number part. So if you look at 2024, questions are asked from oxidation number. An average of one question was there. Then in 2021, then again you can see a question from oxidation number as well as from balancing of redox reaction. Then again in 2020, you will see an oxidation reaction question which involves the involvement of oxidation number. Then coming on to 2019, we have a question from disproportionation reaction. We will cover that part also. Now, let us move on to the first topic. So, the topics that we are going to cover involves the electronic concept of oxidation and reduction. We have known this oxidation and reduction in terms of hydrogen addition or removal or oxygen addition and removal. Got it? But it is more relevant to explain this redox reactions in terms of electron transfer. This is something which is applicable or it is more versatile for various reactions. Whereas your addition of oxygen and hydrogen concept is limited to reactions, particularly in organic chemistry. So there you will see that whenever we add oxygen or whenever we add hydrogen, we have oxidation and reduction respectively. Then we will move on to some important oxidants, means those substances that can oxidize other and in place they are reduced itself. Next, we will see some important reductants as well. Then after, we will move on to oxidation number. So this is the most important concept from which questions are asked, and at the same time, questions from this topic is very easy to solve in your JEE exams. Then after, we will move on to redox reactions. So once you come to know what is this oxidation number, then you will see that how there is a change of oxidation number during a reaction, and hence you can define this redox reactions. Lastly, we will move on to balancing of redox reactions. So we know that there are two methods to do this balancing, which is ion electron method and oxidation number method. We will see both of them. Now, let us begin with oxidation and reduction. So, the definition which is in terms of electron transfer says that when there is a loss of electron by any atom, we call it as oxidation. Whereas, if there is a gain of electron by an atom, we call that atom has undergone reduction, as simple as that. Now, moving on to oxidants and oxidizing agents. Now, this is something which is just opposite to oxidized and reduced species. So, basically, the substances which are reduced, okay? So, if it is getting reduced, it means it is oxidizing some other species. Therefore, we call those species as oxidizing agents. Similarly, those substances which are itself oxidized it will reduce other species and hence it will be named as reducing agents. Now, how do we understand this? As I said in the definition, by oxidation we mean that we are removing electron from the species, and by reduction we mean that we are giving electron to that species. Now, if something is getting reduced, means it is accepting electron, right? Now, from which species it is getting electron? It is making that substance to get oxidized, and hence we call that substance as oxidizing agent. So, if I conclude it in summary, we can simply say that the species undergoing reduction is known as oxidizing agent. Next, what is reductant or reducing agent? So, opposite to that of oxidants or oxidizing agent, the substances which are getting oxidized by losing electron are known as reducing agent. Okay. Moving on to some important oxidants which are used in the oxidation. The most electronegative element such as O2, O3, halogen or molecule composed of the most electronegative element are all important oxidants. Like oxides of metals and non-metals such as magnesium oxide, calcium oxide, chromium oxide are also oxidants. In addition, water, CO2 and oxides of metals and non-metals are all important oxidants which are used in oxidation process. The compound in which an element is in its highest oxidation state. For example, K2Cr2O7 or KMnO4, in which manganese is present in +7 oxidation state. Or you can take the example of HClO4, where chlorine is present in +7 oxidation state. Similarly, you can take the example of H2SO4, HNO3, FeCl3, HgCl2 or KClO3. So, in all these given species, the one of the element of all of these compounds are present in its highest oxidation state. Means it cannot further lose electron. In this condition, it can only accept electron and hence they will oxidize other elements and they are important oxidants. Now, these important oxidants are used in industries also. For example, your KMnO4 is used for oxidation of your alcohol to aldehyde or carboxylic acid also. Got it? So, if you consider more oxidation state such as of your FeCl3. So, FeCl3 has iron in +3 oxidation state and this is the highest possible oxidation state for iron in general. Therefore, it cannot move on to +4 or +5. Therefore, it is only in the condition of accepting electron or going to a lower oxidation state. Therefore, it will oxidize other elements and hence it will act as an oxidant. Got it? You can also try to calculate the oxidation state of chlorine in KClO3 and sulfur in H2SO4. You will see the same result, that these elements in the specific compound are in the highest oxidation state and hence they are acting as a strong oxidant. Next, MnO4-, when in the +7 oxidation state, it acts as a strong oxidizing agent. An oxidizing agent means it will oxidize other and reduce itself because it is in its highest oxidation state. Therefore, it acts as a strong oxidizing agent. In acidic medium specifically, I would say this function is much more depth, okay, has a much more depth and also gives 5 electron per unit formula regardless of the reducing agent. Okay, so what it will do? It will produce 5 electrons per formula unit for the given permanganate ion. Moving on to some important reductants. So you must remember these names, right? So these names of important oxidants and reductants must be in your mind. They are used in the chemical equations, okay, in inorganic reactions as well as organic reactions. Moving on to reductants. So first of all metals like sodium, aluminium, zinc and some non-metals like carbon, sulfur, phosphorus, H2. These are all our reducing agent, that is reductants. Why? Because they are metals, they will lose electrons. Therefore, it will reduce other substances and hence known as reductants. Apart from this, we have sodium hydride, lithium hydride, potassium hydride, calcium hydride. So these metallic hydrides and halogen acids such as HCl, HBr, HI are all acting as a reductant. Okay. So halogen acids are important reductants that are used in reduction reaction. We will see the definition in terms of organic compound when we will move on to organic chemistry, right? So now, right now we are dealing with this redox reaction and we will try to deal mainly with the inorganic reactions. Now, if I say that if your substance is in its highest oxidation state, then it will act as an oxidizing agent or oxidant. Opposite to that, if your element in a given compound is in its lowest oxidation state, then it will act as an reductant or reducing agent. Okay, just wait for a while. We will be back in a minute. Okay, sorry for the interruption. So, is my voice clear? Is there any background noise in this? So, please can you comment it here? Is my voice clear to all of you, or there is a background noise coming during the class? Anyone who can just comment it? So, shall we continue now? Okay. So, as we were talking about this compounds having their oxidation number in the lowest value. Got it? Suppose we take the example of your SN in the SnCl2. So Sn is present already in the +2 oxidation state, and this is the lowest oxidation state possible for the tin element. Therefore, the only possibility it has, it is to go to an higher oxidation state. And when it is possible, it is only possible when it will donate electrons to other, or when it will reduce other species. Got it? So two things are there, and you will remember this is very, very important in many of the questions. This simple logic can solve a difficult problem. What is that logic? That if your element in a given compound is present in its highest oxidation state, that means in that case it can accept electron, or you can say it can oxidize other species. Whereas if it is present in the lowest oxidation state, so there is only one chance, and that is of reducing other elements by by giving electrons to them. Got it? So what is the highest possible oxidation state possible for your tin? Yes, I am IIT and I am from IIT Kanpur. So what is the oxidation state possible for your tin? It is +4, right? So this is the highest oxidation state it can go to. And now, right now, it is present in +2 oxidation state because chlorine is an electronegative element and a halogen. So with respect to halogen, the metal will show a +2 oxidation state, and hence it can only go to +4, which is the highest possible oxidation state possible for tin. Got it? So these are some important points regarding reductants and oxidants. Now, moving on to a very important topic related to redox reactions. Now, this is not specifically asked in your redox reaction part, but instead of that, you will see questions from it from the some basic concept of chemistry part, which is your equivalent weight. We have discussed this part in that class also, but still I will make you remember this because here also some part of the equivalent weight is used to do numericals. Now, what is equivalent weight? Equivalent weight is when a substance reacts by gaining or losing 1 mole of electron. The mass of that substance that comes is called the equivalent weight. As simple as that. Now comes the equivalent weight of oxidizing agent and reducing agent. So it will be different for different species, depending upon whether it is acting as an oxidizing agent or it is acting as an reducing agent. So the formula is simple, only it will depend upon the electron count. For example, if I say that we are telling about the equivalent weight of your oxidizing agent. So how you will calculate it? Very simple. Just simply write the molar mass of the oxidizing agent in the numerator, and in the denominator, since it is an oxidizing agent, so what will happen to it? It will get reduced. And how it will get reduced? By accepting electron. So you can say that equivalent weight of oxidizing agent is equals to molar mass of your oxidizing agent divided by number of electrons gained per unit per formula unit. Similarly, you can tell it for the reducing agent. Got it? So molar mass of reducing agent divided by number of electrons lost by that species. So if I tell you that MnO4, which is having a +7 oxidation state, when it is acting as an oxidizing agent, which is the only possible thing for it, what it will do? It will go to +2 oxidation state, and in that process it will lose 5 electrons. Got it? So if you want to calculate the equivalent weight for the oxidizing agent, which is MnO4, you will take the molar mass of MnO4 and divide it by 5, which is the number of electron it will give to reduce other substance, to oxidize other substances. Okay. Now there are some more examples where the given species are present in the intermediate oxidation state. So it is not present in its highest oxidation state or in its lowest oxidation state. Means it is present in its intermediate oxidation state, and therefore it will act both as an oxidizing agent and a reducing agent as well. So here is the example for that, which is H2O2. So your H2O2 has oxygen in its -1 oxidation state. See, you can just calculate it. It's very simple. If you take the oxidation state of hydrogen, so it is fixed. You can't change it because 1 electron is present at max, and therefore it can only have an oxidation state of +1, since oxygen is more electronegative than hydrogen. Now there are 2 hydrogens. Therefore, +2 is coming from the hydrogen part. Therefore, -2 will come from oxygen part, and since 2 oxygens are there, so -2 divided by 2 oxygen, it will give you -1 for each oxygen. Now here, your oxygen is in an intermediate oxidation state. Why I am telling this? Because there are two paths your oxygen can choose. First path is that it can go to -2 oxidation state, from -1 to -2. You know it is variously available in this -2 oxidation state. Similarly, it can go to 0 oxidation state. For example, if it goes to the O2 form, which is your molecular form of oxygen, so there the oxidation is stated 0. So you can say that oxygen can also go to 0 oxidation state, which is its molecular form, or it can go to its most common -2 oxidation state. In both the cases, we have two different directions. If it will go to -2 oxidation state, means it will get reduced by taking up electron. And if it will go to 0 oxidation state, in that case, it will lose electron, and in that case, it will be oxidized. Since this oxygen in H2O2 can undergo oxidation and reduction both, so it can act as an oxidizing agent and reducing agent. So this is the basic idea behind it. Now, if I ask you that what is the equivalent weight of H2O2, then what will be your answer? If you just go back to the definition of your equivalent weight, it is simply the molar mass of your given substance, whether it is an oxidizing or reducing agent, divided by the number of electrons it is losing or it is gaining. So your oxygen in both the cases will either lose one electron if it is going to 0 oxidation state, and it can gain one electron if it is going to -2 oxidation state. Here, the transfer of number of electrons which are transferred is always 1. Therefore, the equivalent weight of H2O2 will be equals to the molar mass of H2O2, as simple as that. Got it? I hope this is clear to you. So anyone, if you have a doubt, you can ask it. Moving on to the next and the most important part of this chapter, which is oxidation number determination. So there are some rules to calculate the oxidation number for various species. What are those rules? First of all, what is oxidation number? It is a imaginary charge that appears on an atom or a real charge. So it can be both imaginary or real charge which appears on an atom. For example, if you take the case of FeSO4, then Fe and S have a charge. So this charge is real in this case because FeSO4 is an ionic compound. But if you take the case of H2O2, which is a covalent compound, in that case, the charge that you are putting is an imaginary thing. So basically, you are taking your given molecule as ionic compound and then you are assigning a charge which is not exact but close to that. Okay, so it can be real and it can be imaginary depending on the compound which you are considering to calculate the oxidation number. Got it? For example, if you take H2O, there you take the oxidation number of oxygen as -2 and hydrogen as +1. And you know it very well that your water is a covalent compound, so it can never have a +1 and -1 charge. Okay, so that is not something which is possible in covalent compound. But still you assume that this is the charge that can be present on it if it was a ionic compound. Got it? So this is the rationale behind assigning the oxidation number. Next, as I said, we will see the rules for assigning oxidation number. So the first rule is that oxidation number of any element in its elementary state, such as O2, O3, H2, S8, is always 0. So in H2, the oxidation number of hydrogen atom is 0. Similarly, in S8, which is a allotrope of sulfur, there also the oxidation number of sulfur is 0, because in all the atoms, in all the molecules of the compound, the same atom is present. Okay, so whenever you see that same elements are participating in formation of a compound, then the oxidation number of that element in that particular compound will be 0. Next, if you are considering it for ionic species, then a simple rule is applied, which is the electrical charge present on it is its oxidation number. For example, if you take calcium 2+, so in that case 2 will be the oxidation state of calcium. Or if you take Cl-, which is chloride ion, so there your -1 will be the charge for chlorine. So anyone who has a doubt in this? Okay. Next, so for fluorine atom we have a special rule. Fluorine is an exception. It will always have a -1 oxidation state, irrespective of compound you are dealing with. Okay, it will not depend upon the compound. Fluorine has only one possible oxidation state, which is -1. Why is it so? Because it is the most electronegative element, first of all, and it can only take up one electron. So that is the only possibility your fluorine has. Similarly, if you look upon the alkali metal, the same logic can be applied. Suppose you take sodium, you take potassium, you take lithium. All of these elements are alkali metal. And the only one oxidation state which is possible for these alkali metals is +1. Whereas if you consider alkaline earth metals such as your calcium or magnesium, so in those cases, your oxidation state which is possible for this alkaline earth metal is only +2. So these are some important thumb rule which you should remember while assigning your oxidation number. Next, we have some more rules. So if you talk about hydrogen, so hydrogen has a +1 oxidation state always, except in ionic hydrides. Now what are ionic hydrides? You know it very well. You have NaH, which is sodium hydride. You have CaH2, which is calcium hydride. So whenever you take a hydride of metal, in that case, the oxidation number is -1. Whereas in all other cases, the oxidation number of hydrogen is taken as +1. You take an example, take HF, take HCl, take H2O. Just try to calculate the oxidation number. You will always find that in these cases, the oxidation number is +1. Next, nitrogen has two types of oxidation state. So it can be negative or it can be positive. Now, how you will decide it? It's very simple. You have to look upon the element to which your nitrogen is bonded. If it is bonded to less electronegative element, that means it will have a negative oxidation number. And if it is bonded to more electronegative atom, then it will have a positive oxidation number. So this is something which is arbitrary, because nitrogen can have a +5 oxidation state also, -3 also, +3 also. But the nature of the charge is dependent upon the electronegativity of the element to which your nitrogen is attached. Moving on to your oxygen. So oxygen is something which shows a common oxidation state of -2 in most of the cases, until and unless it is attached to a more electronegative element, and that one more electronegative element is only fluorine. So if you see a compound with fluorine, remember it will show a positive oxidation state. For example, in the case of OF2, where fluorine is present in the count of 2, the oxygen will have a +2 oxidation state, because fluorine can only have -1 oxidation state, as I said earlier. Similarly, if you take the case of O2F2, suppose, there the possible oxidation state for oxygen is +1. So these are some anomaly in the case of your oxygen when it is attached to a electronegative element, a more electronegative element as compared to oxygen. Then we have some more anomalies like your peroxides. Okay, so peroxides will have a oxidation number of -1, O2 minus. Similarly, in superoxides, the oxidation number is -1/2. Moving on to fluorine. So you know that fluorine has an oxidation number of -1. You can consider the same for other elements. So for halogens, if it is attached to a metal, okay, I'm not talking about all halogens. So fluorine will always have a -1 oxidation state, but other halogens like your chlorine, bromine, iodine, so these halogens will always show a -1 oxidation state when it is attached to a metallic compound. For example, if you take CaF2 or if you take NaF, there your fluorine is attached to a metal. Or if you take other halogens such as chlorine, so you take the example of CaCl2, right? So since your chlorine is attached to a metal, so it will show a -1 oxidation state. Got it? So remember, this is also very important. When your halogen is attached to a metal, it will always show a -1 oxidation state, or your metal halides will always have a -1 oxidation state for halogen. So this is another way of saying it. Next, in the case of interhalogen compound, where the bond is between two different halogens, there is a possibility that one of the halogen compound will show a +1 oxidation state, whereas the other one will show a -1 oxidation state, and this value will depend upon the electronegativity. For example, if you take the case of ClF3, there the fluorine will show a -1 oxidation state, whereas your chlorine will show a +3 oxidation state. Got it? So this will depend upon the electronegativity of the two halogens between which you are considering your bond. Got it? Then moving on to the oxidation number of metals in amalgam. So amalgam is a type of mixed compound and the oxidation number in carbonyls is always 0. Why it is 0? Because carbonyls are neutral species. So consider this carbonyl compound of iron. So carbonyl is neutral in nature. Since the compound needs to be overall neutral in nature, so you have to keep the oxidation state of iron 0 here. Got it? Moving on to an important note. So this were the rules to calculate the oxidation number. So an important note here is that the valency of an element is always a whole number. Got it? It can neither be 0 nor fractional. But if you consider oxidation number, so it can be negative, it can be positive, it can be 0 or even fractional. You have seen in the case of superoxides where it was -1/2. Then if you consider valency, it is always a whole number. Okay, and it can never be 0 or it can never be fractional, but it can be positive. Got it? Okay, is it clear to all of you? So this is a very important point and an important difference between valency and oxidation number, because valency is something which is related to number of electrons your species will gain or the number of electrons your species will lose. So this is counting. Got it? And counting can never be fractional. You cannot take half electron. It's not possible at all. Got it? Moving on further, we will see the redox reactions and its type. So now you know what is oxidation number and how do you calculate the oxidation number. If you are capable of assigning oxidation number to all the atoms in a given compound, then you can definitely classify your given reaction as redox reaction or not. What is the basic definition of this redox reaction? It's very simple. A reaction that involves both oxidation and reduction in the form of its two-half reaction is known as redox reaction. And it's very obvious also. If something is getting oxidized, it means it is losing electrons. And to maintain the charge, some species should be present there to accept the electron, or else the number of electrons will never be balanced, because the electron loss must be gained by something. Got it? And the species which will gain it, it will get reduced. So this is a couple that cannot be separated at all. If there is an oxidizing agent, there will be a presence of a reducing agent. If there is something getting oxidized, the other species must be present there which will get reduced. Got it? So redox reactions always occur simultaneously. Now what are the types of redox reaction? There are three types of redox reactions. First is intermolecular redox reactions. What are intermolecular redox reactions? So such reactions are those in which reaction occurs between two substances. One is the reductant and the other is the oxidant. For example, if you take the case of this given equation, which is 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4. Here FeSO4 means ferrous sulfate and KMnO4 is acting as an oxidizing agent. As I mentioned, manganese is a common and strong oxidant. So the charge of SO4 is 2-. So the oxidation state of iron will be +2. Got it? So you can see here that oxidation and reduction is occurring between two different substances. Here your KMnO4 is the one and FeSO4 is the reductant. So this is an example of intermolecular redox reaction. Now next, this intermolecular redox reaction can be further classified as combination reactions. So it's very simple. If two atoms or molecules are getting combined and one is getting oxidized while the other is getting reduced, then in that case you will call it as a combination reaction. For example, if you take the case of formation of carbon dioxide, which is formed from carbon and oxygen in the molecular form. Then here carbon is acting as a reductant and oxygen is acting as an oxidant. Why it is so? Just see the oxidation numbers and how it is changing. For carbon, it is going from 0 to +4. Therefore, it is losing electrons and hence it is getting oxidized. Got it? Whereas you take the case of oxygen, so it is going from 0 to -2, so it is getting reduced. Okay, because it is getting electrons. Now you can clearly say that here combination reaction is taking place and the redox reaction is of intermolecular type because reductant and oxidant are two different species. Next we have displacement reaction. It's very simple. You have studied a lot about this in the uh, 9th and 10th class also. So when an atom or an ion in a compound is replaced by other atom and an ion, we call it as displacement reactions. Okay, and these are further of two types. So we will not talk about them in detail. So first is metal displacement, when one metal is displacing the other metal, and second one is non-metal displacement reactions. Okay, is it clear to you? So I hope this is simple to understand what are intermolecular reactions and what are its type. So when oxidant and reductant are two different species, we call it as intermolecular, and when two species are combining together to form one species, we call it as combination. And if one element is or one group of element is replacing other group of element or a single atom, we call it as a displacement reaction. Moving on to the next type of oxidation redox reaction, which is intramolecular redox reaction. So this is something which is interesting to understand. So it involves oxidation of an element of a compound as well as reduction of other element of the same compound. So here we don't have two different species. For example, we take the case of decomposition reaction. So it is essential that one of the product of the decomposition reaction must be in elemental state. What is the example of that? So you take the example of decomposition of NH4 whole twice Cr2O7. Here, if you consider the oxidation state of nitrogen, so nitrogen is going from -3 oxidation state to 0 oxidation state. Got it? So it is going to a higher oxidation state. That means it is getting oxidized. Easy to get. Now take the example of chromium. So what can you tell about chromium? So chromium will have an oxidation state of 7. Okay. Sorry, +6. Chromium will have oxidation state of +6. Now, if you consider its oxidation state on the product side, it will be +3. Got it? So it is going from +6 to +3. That means it is getting reduced. So from this reaction, you can say that chromium is getting reduced, whereas nitrogen is getting oxidized. And hence it is an example of redox reaction and the intramolecular one, since the species which are getting oxidized and reduced are present in the same compound, because nitrogen and chromium both are present in the same compound. Any doubt till this point? So these are some points that you should remember, and you will see questions from it regarding your balancing type. Okay. Any doubt till this point? If you have a doubt, you can just post it in the comment section. Sumant, VK, Dhruv, Partham, Pratham. I hope this chapter is not that much difficult for you, because it involves only the calculation of oxidation number and then the balancing of reaction. Okay. So balancing of reaction has some specific steps, and we need not have to bother much about that. I would try to make sure that you are able to calculate the oxidation number, because there are cases of exceptions where you will do mistake in this easy questions of calculating oxidation number. Is it clear to all of you? Those who are attending the class? Anyone who has a doubt till this part? You can just post it here in the comment section. Or still, if you have a doubt, you can come to our doubt session, which starts from 10 a.m. in the morning and ends at 6 p.m. in the evening. There you can ask your question vocally on the Zoom session, or you can post your specific questions on our SATHEE forum as well. Okay, moving on further. So next, moving on to the further types of redox reaction, which is auto redox or disproportionation reaction. Now, what is this disproportionation reaction? It is similar to your decomposition reaction, but there is a change in its oxidation number change. Okay, there you are seeing that two different species in the case of decomposition reaction, two different species were getting oxidized and reduced, although they were the part of the same compound. Here, you will see that the oxidation and reduction is taking place for the same element. Okay. For example, there is a famous example of your Mn also, and here you can take the example of chlorine. So, see here, the chlorine is present in the molecular form. So, what will be the oxidation state of chlorine here? Can you just tell me what is the oxidation state of chlorine in the reactant side? Anyone, can you please comment it here? What will be the oxidation state of chlorine in the reactant side? Just try to assign the oxidation number for chlorine for each of this case. So we have chlorine in the reactant side also and chlorine in the product side also. So first try to assign the oxidation state for chlorine in the reactant side. Since it is present in molecular form where the two atoms are same, means the chlorine is attached to another chlorine only. Therefore, the oxidation state of chlorine will be 0 here. Got it? Now, if you look upon to the product side, then in the product side we have two places where chlorine is present. In this chloride ion, you know it very well that for an ion, the oxidation number is the charge present on that ion. Therefore, the oxidation number will be -1. So, chlorine is going from 0 to -1. So, it is getting reduced. Whereas, if you take the case of ClO- and try to calculate the oxidation number of chlorine, so what will be the oxidation number? So, for oxygen, it will be -2. And if -1 is left, that means this chlorine is present in +1 oxidation state. So, it is going from 0 to +1 and 0 to -1, meaning that your chlorine is getting reduced on going from chlorine to chloride, and it is getting oxidized on going from chlorine to ClO-. Okay, I hope this is clear to you. Now, moving on to the last part of our today's theory lecture, which is balancing reactions. So there are two methods to balance a given redox reaction. What are those methods? First is ion electron method. In ion electron methods, there are several steps. First one is you write the redox reaction in ionic form. Okay. Then you split the redox reaction in two halves. Oxidation half reaction and reduction half reaction. Then after, you balance atoms of each half by using simple multiple. So these are the three steps. Now moving on further, how you will balance other atoms? So there is a special methodology for that. First of all, you balance hydrogen and oxygen. How do you balance it? So if the reaction is carried out in acidic medium, you have to add H plus ion. Where it is less in amount, you add that same amount of H plus ion as per the required reaction. Then after, you add H2O to the appropriate side to balance your oxygen. How you will do it? So first try to balance oxygen by adding H2O. Then try to balance hydrogen by adding H plus. Then you will find it easy to do so. Next, what you will do in the case of basic medium? So repeat the first step, and after that add the same number of OH minus, which is equals to the H plus ion you have added. Okay, on both sides. What did I say? So in case of acidic reaction, you first balance oxygen atom by adding H2O on the appropriate side. Then after you balance hydrogen atom by adding H plus on appropriate side. This is clear? This is for acidic medium. Now for basic medium, you have to add one more step. What is that step? So you have to add the same number of OH minus as much as your H plus you have added on both sides. Got it? So we'll talk about this when you will do a question. Next, you have to balance the charge. Okay, after balancing all the elements in the two half reactions, you have to balance the charge. And how you will balance it? You will use electrons to do so. Okay, so where there is a higher positive charge, you will simply add electrons to balance the reaction in charge sense. Now, the last part is adding two reactions. Before adding two reactions, you will make the electron count equal in both the reactions. Then and then only you will add it. Suppose in the redox, in the reduction half reaction, the electron count is 2. Whereas in the oxidation half reaction, the electron count is 4. Okay, so what you will do? You will simply multiply the reduction half reaction with 2. The whole reaction with 2. That will make the electron count 4. Now you will add it, and when you will add it, the electrons will get cancelled out and you will get your balanced redox reaction. I hope this is clear to you. So this is something in which this is the way you balance your reaction in ion electron method. So let me repeat my steps. What you will do? First, you will write your given reaction and split the given reaction into two halves. Reduction half reaction and oxidation half reaction. So this is the first step. Next step is balancing the elements. So first of all, balance all other elements except hydrogen and oxygen. Now, when it comes to hydrogen and oxygen, first you will balance oxygen by using H2O, by adding H2O of appropriate count on the reactant or product side. Then to balance hydrogen, you will add H plus. So this was for your acidic medium. Now for basic medium, you will do one more step. Okay, after adding H plus, you will do one more step. What is that step? You will simply add the same number of OH minus as that of H plus on both sides of the reaction. Got it? After doing this, you have a completely balanced half reaction set. Then you need to balance the charge. How you will balance the charge? By using electrons. So where there is more positive charge, add the appropriate number of electrons. Now is the term to add both the half reactions. How you will add it? It's very simple. You have to first make the electron count equal in both. By how? By multiplying with a common factor. Then you will add both of the reactions and it will give you your final reaction where your equation is completely balanced. Got it? So moving on to the next method of balancing, which is your oxidation number method. Let's see how we can use it to balance a reaction. So the steps involved in balancing a reaction, redox reaction with oxidation number methods are: first, assign an oxidation number to each atom in the equation. Then, secondly, write separate equations for each. Only when you assign, you will know that which is the oxidation half, which is the oxidation reaction, and which is the reduction reaction. Meaning that you will come to know that which species is getting oxidized and which species is getting reduced. Got it? Then after, find the charge in the oxidation number, change in oxidation number in each equation, and make that change equal in both the equations by multiplying with suitable integer. After that, equate the change in both equations by multiplying with suitable integer, multiply by whatever number is needed, and equate the change in oxidation number. Okay? So these are the two methods by which you can balance a redox reaction. So this was all about the theory part. Now you will see questions on it. So just wait for a while. Meanwhile, if you have a doubt, you can ask it here in the comment section. So this is your first question. So I have taken a question from NCERT examiner since it was a good example for your JEE exams. You will absolutely see question references from examiner of your NCERT in your JEE exams as well. So the question is saying that your MnO4 2- is undergoing a disproportionation reaction in acidic medium. Okay, but your MnO4- does the same. What is the reason behind it? So what did I say? I said that if you want to see a species undergoing disproportionation reaction, it means that it should get oxidized also and it should get reduced also. Okay, so this is the definition of your disproportionation reaction. Now, it is only possible when your given species is present in an intermediate oxidation state. Okay, so that from that point it can go to a higher point also or to a lower point also. Okay, so that is the basic idea behind this question. Now, let me explain it properly with the help of equations. So, species which are present in the intermediate oxidation state, they are only capable of doing a disproportionation reaction, means going on to oxidized state as well as reduced state. Very good, VK. Yes, so Mn is in the highest oxidation state in the case of MnO4-, therefore disproportionation is not possible in that. Now, if your species is present in a maximum or a minimum oxidation state, it cannot undergo disproportionation reaction. Suppose if you take the case of MnO4 2-, here MnO4 2- has +6 oxidation state for manganese. So it can go to 2 oxidation state. The highest one is +7, so it can go to +7 to form the MnO4-, or it can go to a lower one, which is +4 in the case of MnO2. So you can say that your manganese can undergo disproportionation reaction in the case of MnO4 2-. But if you consider the case of MnO4-, what will happen? This thing is not possible there because manganese is already present in its highest oxidation state +7. On contrary to that, here manganese is present in the +6 oxidation state. Hence, it can go to +6 to +7 in acidic medium because oxidation number can increase up to a maximum of +7 for manganese. Whereas, if you see it for your Mn to MnO2, it can go to a lower oxidation state of +4. Okay. Next, this thing is not possible for MnO4 as it is already present in its highest oxidation state, which is +7. So we can write it here in the terms of equations. If you take MnO4- in the acidic form, then it shows the reaction of MnO4- 8H plus 5 electron going to Mn2 and 4H2O. Here you can clearly see that manganese is going to +2 oxidation state, and this is the only possible oxidation state, lower possible oxidation state possible for manganese in case of +7. But if it can go to a plus higher oxidation state, which is not possible here because the maximum number of manganese electron in the valence shell is +7. Okay, so it cannot lose further electrons. Therefore, it cannot increase its oxidation number further. And hence we can say that, or you can say we can rationalize that your MnO4- cannot undergo disproportionation reaction. Okay, I hope this is clear to you. So we can conclude finally that MnO4- cannot undergo disproportionation reaction because it cannot oxidize further. Why did I give this theoretical question? So this is sometimes asked in your JEE exams in terms of statement wise. Okay, therefore it is important to deal with such questions also. Now moving on to the next question, which is an example of balancing reaction. So here what are we doing? We are balancing this given reaction of I2 plus NO3- going to NO2 IO3-. So most of the students find it easy to balance it through the method of half oxidation method. Okay, so they find it easier. So I will explain the difficult method, which is oxidation number method. Okay, here you don't divide your reaction into two halves, rather than you balance the reaction in the equation given itself. Let's see how can we do it. So starting with the reaction, so this is our given reaction, I2 plus NO3 minus giving to NO2 IO3 minus. So this is your skeletal equation. So what is skeletal equation? You know it very well. You must have studied this term in your earlier classes. A unbalanced equation is known as a skeletal equation. Next step in the ion electron method is that you assign oxidation number for each atom. Okay. So for I2 it will be 0. In case of NO3 minus, N will have plus 5 and oxygen will have plus minus 2. Similarly, in the product side, NO2, nitrogen will have plus 4 and oxygen will have minus 2. If you talk about IO3 minus, here the iodine will have plus 5 and oxygen will have minus 2. Now you can clearly see that which species are getting oxidized and which are getting reduced. So let me just list them here. So from the given equation, we can clearly say that your iodine is getting oxidized since it is going to a higher oxidation state, which is plus 5, and your nitrogen is getting reduced as it is going from plus 5 to plus 4, which is a lower oxidation state. So this is the second thing. So first what you do, you write the skeletal equation. Second, you assign the oxidation number as done by me in the first part. Then you specify the species which are undergoing reduction and which are undergoing oxidation. Now we will try to see the change in oxidation number that is occurring in the given equation. So we will calculate the change. That means increase and decrease both. So if you look at the given skeletal equation, you can clearly see that your iodine is going from 0 to plus 5. So this is for one iodine atom. Okay. Now if you look upon the equation, there are two iodine atoms. Therefore, for two iodine atoms, the total change will be of 10. So therefore, there is a plus 10 change when you are going from reactant onto product side for iodine. So this is for your oxidation. But if you consider it for nitrogen, it is going from plus 5 to plus 4. That means a change of plus 1, and there is only one nitrogen present on the reactant as well as product side. Therefore, the change is of plus 1 for each nitrogen atom. Okay. So what did we see? We saw two things. First thing is that your iodine overall is showing a plus 10 change on going from reactant to product side, whereas your nitrogen is showing a change of 1. Okay. So next thing is to balance this change. So this should be 10 in both the parts. Okay, in the oxidation as well as reduction. How you will do it? It's very simple. So this was our equation, and you have to balance the increase and decrease. So first of all, we will try to balance the iodine molecule at the first place, because here it is 2 and here it is 1. So we'll multiply 2 on the iodine. Next, we'll multiply 10 on the nitrate ion as well as nitrogen oxide. Why we are doing it? Because iodine is showing a 10 oxidation state change, and for each nitrogen the change is 1. So for making it a change of 10, you will multiply 10 on both sides of the compound containing nitrogen, which is nitrate ion and the nitrogen oxide. Okay. After doing that, you will get your equation as I2 in the gaseous state going to 10 NO3 minus in the aqueous state, giving us 10 NO2 in the gaseous state plus 2 IO3 minus in the aqueous state. Okay, I hope this is a simple thing to do. What did we do? We first calculated the change which is undergoing during oxidation and reduction. For oxygen, for iodine it is of 10 if you consider 2 iodine atoms, and for nitrogen it is of 1. So the change in oxidation number is higher for the case of oxidation. We have to make it same for the reduction. How do we do it? We multiply 10 as a coefficient for NO3 minus and NO2 because both of them contain nitrogen in them. Got it? Now we can say that the change in oxidation number is same in both oxidation and reduction. What is the next thing? The next thing is to balance the ionic charge. How you will balance it? Since it is given that the reaction is in acidic medium, therefore you will balance it by adding a positive charge in terms of H plus ion. Okay. If you look upon the reactant side, then you will notice that what is the overall charge? That is 10 negative. Okay, NO3 minus, so 10 negative. Whereas in the product side, it is 2 negative. Because two species are only there which are charged, NO3 minus and IO3 minus. Against NO3 minus we have 10, against IO3 minus we have 2. Therefore, the negative charge on the left hand side is 10 minus and the negative charge on the right hand side is 2 minus. Now to make the charge equal, you have to make it minus 2 on both sides, and it will be done by adding 8H plus on the reactant side. Okay. So this is the way you balance the charge. I hope it is clear to this point. Next, we will finally equalize the hydrogen atom. So this is the last part which is yet to do. And how you will do it? By adding H2O molecule on the right hand side. So there are 8 hydrogens on left hand side, whereas no hydrogens on the right hand side. So if you add 4 H2O here, so 4 into 2, 8 hydrogens are added on the product side. Therefore, we get our balanced equation for the given redox reaction. Got it? I hope this is clear to you. So these are the 2 exemplar problems that I find that they are important for you. So I solved it for you. Just try it by yourself once more, especially this balancing part using the ion electron method. Meanwhile, I will now switch on to the PYQs. Okay, just wait for a while. Let me open the PY. So here is the first question. So these questions will be mainly focused upon your oxidation number. Okay, just quickly try to calculate the oxidation number and remember the rules to know a reductant or an oxidant. You have to decide that out of the given species, which will not act as an reducing agent. Remember, the substances which are already present in the lowest oxidation state, those species are not capable of acting as a reducing agent. So just try to find out that which one is present in its lowest oxidation number, and just poll it here that which one will be the correct answer. So you have SO2, H2O2, CO2 and NO2. Remember how you will do it? You have to find the species which is already present in its lowest oxidation state. So in that case, it cannot donate electron further, and hence it cannot act as an reducing agent. You can either comment it here or you can just vote it in the vote section. First, let me try it for SO2. If you calculate sulfur's oxidation state, it is +4 here, because oxygen is present in -2 oxidation state and 2 oxygens are there. So a multiple of 2 along with -2 will give you -4 oxidation state. Therefore, sulfur will have a +4 oxidation state. Okay, I am already seeing answer as C. Okay, let us verify it if it is correct or not. Now coming on to H2O2, we have seen it in the example also that H2O2 has oxygen in -1 oxidation state, and it is an intermediate state for the oxygen. Since it is an intermediate state, it can go to an higher oxidation state or even to a lower oxidation state. Therefore, both is possible for H2O2. Whereas if you consider it for CO2, so CO2 is already present in its lowest oxidation state, which is -4. Okay, it cannot accept electron further. It's not possible for it. Therefore, this is the highest oxidation state for carbon. Now take the reference of organic. If you oxidize any given species using harsher and harsher condition, first it will go from a normal to alcohol, alcohol to aldehyde, aldehyde or ketone depending upon the species you have taken, then to carboxylic acid, and lastly to carbon dioxide. After that, you cannot oxidize this further. So from that point also you can calculate it, or if you try to calculate the oxidation number also, you will find it as -4, and -4 is the least number of oxidation state possible for carbon. Okay. Therefore, the correct answer will be C. Very good, VK. Now moving on to NO2, if you calculate it for NO2, the nitrogen will show a +4 oxidation state. Your nitrogen is capable of showing a +5 also, and a lower one also, it can go to -3 also. So this is obviously not the least oxidation state for nitrogen. Therefore, the correct answer will be C. So as I said earlier, since carbon is having a +4 oxidation state, therefore it cannot act as a reducing agent. Moving on to the next question. In which of the following reactions nitric acid acts as a reducing agent? Your 4 options are given here. Just try to assign the oxidation number to each of the nitric acid species, and then you will get your answer. Okay, what you have to do, just try to assign the oxidation number for each of this given reactions. So let me start with the second one. Okay, so what is the oxidation number of nitrogen? First of all, in the nitric oxide, it will have a +2 oxidation state. Now, since it has to act as a reducing agent, therefore it should undergo oxidation. Means it has to increase its oxidation number. If you calculate its oxidation number in the case of N2O here in third and fourth reaction, then what will happen? There it will show a +1 oxidation state, right? That means it is going from +2 to +1. Hence, it will act as a oxidizing agent and not a reducing agent. Got it? Because it is getting reduced here. Whereas if you take the case of option number B, so 3 to the 6 minus 1, 5. So it is going from +2 to +5, which is even a higher oxidation state. Therefore, it will act as a reducing agent because it is getting oxidized here. Is it clear to you? It's a very simple question. Just try to assign the oxidation number in each case. You will easily get your answer. First option is already out of pole because here NO is not present in the reactant side only. Got it? So you have to consider the other 3 reactions. Just comment it here, or else you can just vote it in the given poll. I would suggest you to give it in the comment section if you are comfortable, or else you can vote it in the poll. Got it? Both options are available for you. But please do it quickly. Okay, so let me move on to the correct answer. Of course, the correct answer, as I said, and as VK said, it is B. Now, how will be the solution? It's very simple. Just assign the oxidation number to the B option. So here it is +2 and it is going to +5. So there is an increase in oxidation number, means it is undergoing oxidation. And hence we can call your nitric oxide acting as an reducing agent. Got it? Moving on to the next question. So which one of the following cannot function as an oxidizing agent? Again, a simple one. You have to see that which one cannot act as an oxidizing agent, means which cannot be reduced further. Okay. So 4 options are given here. Just think about it. I minus, S, NO3 minus, Cr2O7 2 minus. If you have your answer, please just vote it here, or you can write it in the comment section as well. So can you tell me in which of the species it is already present in its highest oxidation state. Sorry, lowest oxidation state. First one is I minus. Here iodine is present in its -1 oxidation state. For sulfur it is 0. Then for NO3 minus, if you consider, it is in +5. Okay, 3 to the 6 minus 1 plus 5. Then for Cr2O72 minus, 7 to the 14 minus 2, it is 12 by 2, which is +6. So in C and D, it is present in its highest oxidation state. So it can easily get reduced. Therefore, they can act as an oxidizing agent. If you consider the case of sulfur, again, it can show a 2 minus also, or it can go to a +6 oxidation state also. Therefore, it can also act as an oxidizing agent. But if you take the case of I minus has a negative oxidation state, and this is the least possible for it. So the correct answer is I minus, because this is the minimum oxidation state possible for iodine. So it can not function as an oxidizing agent. Got it? I hope this is easy for you. Next question. In which of the following reactions hydrogen is acting as an oxidizing agent? First one is with iodine to form hydrogen iodide, means H2I2 giving us 2Hi. Second, with lithium to form lithium hydride, means simple Li reacting with hydrogen to form the lithium hydride. Then nitrogen and hydrogen to form ammonia. Then your sulfur and hydrogen to form hydrogen sulfide. You have to tell that in which case it is acting as an oxidizing agent. Okay. So again, just write the reaction, assign the oxidation number, and then try to see that in which of these cases your hydrogen is acting as an oxidizing agent, means it is getting reduced and oxidizing other species. Just simply write the chemical equations related to each reactions and then assign the oxidation number. This will give you an idea that which one is acting as an oxidizing agent, in which case your hydrogen is acting as an oxidizing agent. So let me start with iodine. So if you add hydrogen to iodine, it will form I2. So hydrogen will go from a 0 oxidation state to +1 oxidation state. Therefore, it is getting oxidized, means it is acting as a reducing agent. But if you consider it for lithium, then with lithium it is going from 0 to -1, means it is getting reduced. Okay, because hydrogen shows a +1 -1 oxidation states only with the metals when it forms metals hydride. Therefore, here lithium is going to a oxidation state of +1 from 0, means it is getting oxidized, and that is done by hydrogen. So in this case, the correct option will be B. Now moving on to the incorrect options. Consider the case of nitrogen. Here also the nitrogen is going from 0 oxidation state to a -3 oxidation state. So it is getting reduced. Therefore, hydrogen is not acting as an oxidizing agent. Similarly, you take the case of sulfur. Sulfur is also getting reduced here. Therefore, here hydrogen is acting as a reducing agent. Got it? So I am seeing two answers, which is B. Okay, it is very simple. Just simply write the equation of lithium reacting with hydrogen to form lithium hydride. You can clearly see that your hydrogen is going from 0 to -1, means it is getting what? It is getting reduced, whereas your lithium is getting oxidized. Therefore, what we can say, that lithium is acting as a oxidizing agent here. Sorry, hydrogen is acting as an oxidizing agent here. Okay. Moving on to the last question of today's class. The compound that can work both as an oxidizing as well as reducing agent is, again, so this is something which we have done in the examples as well. It's a simple one. You have to see that which of the given species can undergo both oxidation and reduction, and this is only possible when your given species is present in the intermediate oxidation state. Okay. So 4 options are here: KMnO4, H2O2, Fe2SO4 whole thrice, and K2Cr2O7. If I go through them quickly, you will find that manganese is present in +7, oxygen is present in -1, and your iron is present in +3, whereas your chromium is present in +6. Now the question comes, which is the highest oxidation for manganese? It is +7 and it is already present in that state. It means it cannot undergo oxidation further. Same can be said for chromium and iron, because chromium is present in its highest oxidation state of +6 and iron is present in its highest oxidation state of +3. Now, if you just put your eyes onto oxygen, there you will find that the highest oxidation state is not reached. Either the lower oxidation state is also not reached, and it is present in the intermediate form, which is -1. Therefore, the correct answer will be H2O2. So you can say that in the solution, you can clearly say that as your H2O2 has oxygen in -1 oxidation state, so it can go to 0 in the molecular form and it can be oxidized. Similarly, it can go to -2 and get reduced, which is the reduction. So this was all for today's class. I hope you enjoyed the lecture. Thank you for joining the session. Thank you, VK. Thank you, VIP. Just try to be regular in this series. I hope your preparations are going well, and we will come with flying colors in the end of the result.
Hello students, welcome to 40 days JEE crash course. In this lecture, we will first discuss theory part of differentiation and then we will discuss practice questions 1 differentiation. So let's get started. This is our disclaimer. In today's lecture, first we will cover derivative. There we will tell you what is derivative, and how to find derivative of a function, and then we will tell you derivative of some standard function. So there are some standard function, and there we will see derivative of their. After that we will discuss methods of differentiation. So there are some method, one differentiation, that we will discuss in this lecture. Then we will see differentiation using substitution. So sometimes our expression will be complicated. That case, by using substitution, you can simplify that complicated expression and then you can differentiation. After that, we will discuss second order derivative. Okay, so if we differentiate first order derivative with respect to x again, then you will get second order derivative. So we will talk about second order derivative, and finally in theory part we will discuss differentiation of a determinant. So there we will see if our function in the form of determinant, then how to find derivative of a determinant. So I hope you are with your notebooks and pens ready. So let's get started. First topic here. So first we will discuss derivative. So what does mean derivative? Do you have any idea about derivative? What is derivative? So see here, the rate of change of a quantity y with respect to another quantity x is called the derivative. Okay, that means if you have two quantity y and x, and now you want to find the rate of change of a quantity y with respect to another quantity x, then this rate of change is called the derivative. Okay, or you can call differential coefficient of y with respect to x. So derivative or differential coefficient of y with respect to x, they are same. Then the process of finding derivative of a function, so this is called differentiation. So what is differentiation? The process of finding derivative. And what is derivative? The rate of change of a quantity y with respect to another quantity x. This is derivative. Okay, and the process of finding derivative of a function called differentiation. Clear? Understand? Now we will tell you geometrical meaning of derivative at a point. So what is the geometrical meaning of derivative at a point? So suppose you have a point and you want to know the geometric meaning of derivative. So how to see this? So geometrically derivative of a function at a point x equals c is nothing but the slope of the tangent to the curve y equals f of x at the point p of c comma f of c. So if we find the slope of the tangent to the curve y equals f of x at the point p of c comma f of c, then this is actually the geometrical meaning of derivative of a function at a point x equals c. Clear? So if you want to find derivative of a function at a point x equals c, just you have to find the slope of the tangent to the curve y equals f of x at the point p of c comma f of c. Clear? Understand? I hope you will understand. Okay. So now see here, what is the slope of tangent at point p of c comma f of c? The slope of tangent at point p of c comma f of c is equal to limit as x tends to c of f of x minus f of c divided by x minus c. Okay, so this is actually limit form of slope of tangent at point p, and you can also write it as d f of x upon dx at x equals c, or you can write f prime of c. So this is slope of tangent at p. Clear? So this is the slope of the tangent of the curve y equals f of x at the point p of c comma f of c. So now you can visualize in the figure. In this figure you can see this is our curve. This is blue color. This is actually our curve y equals f of x. Okay, and your point p at c comma f of c. This is our point c comma f of c, and then we take very small quantity h which is greater than 0, and here you will get by adding c with a h, c plus h and f of c plus h. You get the point here, c plus h comma f of c plus h. Okay, now connect point c comma f of c and point c plus h comma f of c plus h. Then you get this chord. Okay, this is our chord joining the points c comma f of c and c plus h comma f of c plus h. Clear? Then how to find tangent at point P? So this line which passes through the point P of c comma f of c, this line is called tangent at c comma f of c. Clear? So this is the, now if we find the slope of tangent at P, that is equal to limit as x tends to c of f of x minus f of c divided by x minus c. Okay, and this is equal to df of x upon dx at x equals c or f prime of c, and this is actually the derivative of a function at a point x equals c. Clear? Understand? Do you have any doubt? All you understand? So here in this slide we have seen what is derivative or differential coefficient of y with respect to x, and then we see what is differentiation. Okay, and then we have seen here geometrical meaning of derivative at a point. Clear? All concepts are clear here? Do you have any doubt? I think you have no doubt. Okay, so now let's move to the next. So now we will discuss derivative of some standard function. Okay, so there are some standard functions, then here we will see derivative of the. So see first, what is the derivative of constant? You all know the constant function. When the function f of x equals k, where k is a constant, okay, this type of function is called constant function. So what is the derivative of constant function? So d upon dx of constant is equal to 0. Okay, so you should keep in your mind, if you differentiate constant number or constant function, that is always 0. Okay, so d upon dx of constant is equal to 0. Then see here, derivative of x to the power n with respect to x. What is the derivative of x to the power n? D upon dx of x to the power n is equal to n times x to the power n minus 1. Okay, this is called power rule. Clear? So d upon dx of x to the power n is equal to n times x to the power n minus 1. Suppose you have the function x cube. So what is the derivative of x cube? So by using this standard derivative of standard function, d upon dx of x to the power n equals n times x to the power n minus 1, you can find derivative of x cube. Here n is 3. Okay, so the derivative of x cube, that is d upon dx of x cube, is equal to 3 times x to the power 3 minus 1, that is 3 times x square. Clear? Understand? Next, see d upon dx of square root of x. So how to find derivative of square root of x? So you can write square root of x as x to the power 1 by 2. Okay, so if we write square root of x as x to the power 1 by 2, then if we apply the above formula, that is d upon dx of x to the power n is equal to n times x to the power n minus 1, then you will get d upon dx of square root of x is equal to 1 by 2 times square root of x. Okay, how? You can see here, if we have x to the power 1 by 2, here n is 1 by 2. Okay, so x to the power 1 by 2, if we now differentiate with respect to x of x to the power 1 by 2, so then d upon dx of x to the power 1 by 2, this is equal to 1 by 2 times 1 by square root of x. How? 1 by 2 x to the power 1 by 2 minus 1. Okay, this is 1 by 2 times root x. Clear? Understand how we obtain derivative of square root of x? Now see derivative of 1 by x to the power n. So 1 by x to the power n is basically reciprocal function of x to the power n, and we will know d upon dx of x to the power n is n times x to the power n minus 1. Now what is the derivative of 1 by x to the power n? So d upon dx of 1 by x to the power n, you can write it as d upon dx of x to the power minus n. Okay, so then you can use this formula and you will get minus n times x to the power minus n minus 1. Okay, that is minus n upon x to the power n plus 1. Clear? So d upon dx of 1 by x to the power n is equal to minus n by x to the power n plus 1. This is how we obtain differentiation of 1 by x to the power n with respect to x. Clear? Understand? Next, d upon dx of sin x is equal to cos x. Okay, so you should keep in your mind differentiation of sin x is cos x. D upon dx of sin x is equal to cos x. Then see, d upon dx of cos x is equal to minus sin x. Okay, so derivative of sin x is cos x and derivative of cos x is minus sin x. Then see, d upon dx of tan x. What is d upon dx of tan x? D upon dx of tan x is sec square x. Okay, clear? And then d upon dx of sec x. D upon dx of sec x means the derivative of sec x with respect to x is sec x times tan x. Clear? So you should keep in your mind these derivative of some standard functions. And then see, d upon dx of cot x is equal to minus cosec square x. After that, d upon dx of cosec x, this is equal to minus cosec x times cot x. Very simple formula. They are basic some derivative of standard functions. Then d upon dx of log x, this is equal to 1 by x for x should be greater than 0. Okay, so for x is greater than 0, derivative of log x is 1 by x. Then derivative of e to the power x is e to the power x. So derivative of e to the power x, derivative exponential function remain same. Okay, so d upon dx of e to the power x, this is equal to e to the power x. Then see, d upon dx of a to the power x, this is equal to a to the power x times log a for a is greater than 0. Okay, so if you have the exponential function a to the power x, then you should keep in your mind the formula d upon dx of a to the power x is equal to a to the power x times log a for a is greater than 0. Why? Because if you take a is negative, then the log function of a not defined. Okay, so here a should be greater than 0. Then you can define derivative of e to the power x, that is e to the power x times log a. Then see, if we have the standard function log base a of x, then d upon dx of log base a of x, this is equal to 1 by x times log a for x is greater than 0 and a is greater than 0 and a is not equal to 1. Clear? Then see here, d upon dx of sin inverse x, this is equal to 1 by square root of 1 minus x square, and this is defined for minus 1 less than x less than 1. Clear? So how to prove d upon dx of sin inverse x is equal to 1 by square root of 1 minus x square? How to prove it? So for proving this, you first let y equals sin inverse x. Okay, so if we let y equals sin inverse x, from there you will get x equals sin y. Okay, x equals sin y. Now differentiate with respect to x. So in left hand side you will get 1, and right hand side you will get cos y times dy upon dx. Okay, and then after simplifying you will get dy upon dx equals 1 by cos y. Okay, and you have sin y equals x, so cos y is square root of 1 minus x square. So d upon dx of sin inverse x is 1 by square root of 1 minus x square. Clear? Understand how we obtain d upon dx of sin inverse x? So d upon dx of sin inverse x is equal to 1 by square root of 1 minus x square, and this is defined for minus 1 less than x less than 1. Clear? Understand? Do you have any doubt? I hope you all understand and there is no doubt. So now moving to the next. Then d upon dx of sec inverse x, this is equal to 1 by modulus of x times square root of x square minus 1 for mod of x is greater than 1. When mod x is greater than 1, then derivative of sec inverse x, this is equal to 1 by mod of x times square root of x square minus 1. Okay, then d upon dx of cosec inverse x, d upon dx of cosec inverse x, this is equal to minus of 1 by mod of x times square root of x square minus 1 for mod of x is greater than 1. Okay, just you should remember this formula. don't need proof. Okay, then d upon dx of tan inverse x is equal to 1 by 1 plus x square. Here for x is belongs in set of real numbers. Then d upon dx of cot inverse x, this is equal to minus 1 upon 1 plus x square. Okay, for x belongs in set of real numbers. So you should keep in your mind the derivative of these standard functions. They are very basic formula. Okay, you should keep in your mind, and this formula will be used to solve many problems. Okay, best one differentiation, best one integration. Okay, so there you will use this formula. So you should keep in your mind these formulas, very important formulas there. Okay, clear? Then moving to the next. Now we will learn some methods of differentiation. So there are some methods of differentiation that now we will learn, that will help to differentiate complicated expressions. Okay, so first see here, if you have y equals f of x plus minus g of x, then what will be the dy upon dx? So dy upon dx is basically equal to d upon dx of f of x plus minus of g of x. Okay, and this is equal to f prime of x plus minus of g prime of x. So if you have the function like addition or subtraction of two functions, then the differentiation dy upon dx is simply addition or subtraction of derivative of the function f of x and g of x. Clear? Very simple. And if your function y equals c times f of x, where c is any constant, then what will be the dy upon dx? So dy upon dx, this is equal to d upon dx of c times f of x. Okay, and here c is constant, so it will come up outside, then you will get dy upon dx is equal to c times f prime of x, and this rule is called scalar multiple rule. Clear? Then see, if your function y equals f of x times g of x, then how to find dy upon dx? So if your function like product of two functions, so then dy upon dx, this is equal to d upon dx of f of x times g of x. Okay, so to find the derivative of y equals f of x times g of x with respect to x, just you first have to fix the function f of x and then derivative of second function g of x. Okay, then multiply them and then use addition and then fix second function and derivative first function and multiply them. Okay, so if we add f of x times g prime of x plus g of x times f prime of x, then you will get the derivative of y equals f of x times g of x, and this rule is called product rule. So you will use this formula to find the derivative of product of two functions. Okay, so you should keep in your mind this formula, very important formula, this one. Then see here, if your function y is f of x by g of x, then how to find dy upon dx? So here your function y equals f of x by g of x, and here g of x is not equal to 0. So now for finding dy upon dx, you first fix the second denominator function g of x and but differentiates numerator function f of x. Okay, and multiply the g of x times f prime of x, and then take you negative sign. Okay, minus, then you multiply f of x and g prime of x, and you divided the whole thing by g of x whole squared. Okay, so this is how you find the derivative of y equals f of x by g of x. Clear? Understand? So suppose you have the function y equals x plus 1 divided by x minus 1. So how to find dy upon dx? So you have the function y equals x plus 1 divided by x minus 1, and here this function is defined when x is not equal to 1. So what is the derivative of y with respect to x? What is dy upon dx? Everyone write in chat section. What is dy upon dx for the function y equals x plus 1 divided by x minus 1? So use cosine rule and find the derivative of y equals x plus 1 divided by x minus 1. Everyone do it and give your answer in chat section. What is the derivative of y equal to x plus 1 by x minus 1? Do it, quickly do it. Very simple, just you have to apply cosine rule. Okay, and you can easily find dy upon dx. Very simple. So everyone try it. So now next see the next method, that is if your function y equals f of u and u equals g of x, then what will be the dy upon dx? So here basically you have y equals f of u and u equals g of x. That means the function y equals f of g of x. Okay, that means the function y is composite function of f and g. Okay, you can write also it as f composition of g of x. Okay, that is actually f of g of x. So now how to find dy upon dx? So you have the form rule, chain rule. Okay, so when you have your function like a composite function like y equals f of g of x, this type of function, then you can apply chain rule. Okay, so here you have y equals f of u and u equals g of x. So then dy upon dx, this is equal to, first you differentiate f with respect to u, then you differentiate u with respect to x. Okay, and here you can write dy upon dx, this is equal to df upon du times du upon dx. Okay, and this is equal to f prime of u times g prime of x. Clear? So this is how you can differentiate composite function. Understand? Clear? Everything is clear to all of you? Yes, good. So here now take one example for cos chain rule. Okay, so you have the function y equals sine of cos x, sine of cos x. Okay, so you have to find dy upon dx. So what will be the dy upon dx for y equals sine of cos x? Everyone wait and write your answer in chat section. What is the derivative of y equals sine of cos x with respect to x? Using here chain rule and find the derivative of y equals sine of cos x. Everyone do it. Very easy. Here you have to use chain rule. Okay, and here we have discussed chain rule. If your function y equals f of u and u equals g of x, then du up dy upon dx, this is simply equals, first you have to differentiate f with respect to u, then you have to differentiate u with respect to x and then multiply them. Okay, and then you will get the dy upon dx. So dy upon dx equals f prime of u times g prime of x. Yes, good, very good, excellent, you are doing good. So now move to the next. So this rule can be extended as follows: if y equals f of u and u equals g of v and v equals h of x. Okay, so you have basically the function y is equal to f of g of h of x. Okay, so if you have this type of function, that case you can also apply chain rule. Okay, so in this case, how to find dy upon dx? So if your function y equals f of u and u equals g of v and v equals h of x, then dy upon dx, this is equal to df upon du times du upon dv times dv by dx. This means you first differentiate f with respect to u, because your function y is basically function of u. Okay, and then you differentiate u with respect to v, because your function u is function of v. Okay, so you differentiate u with respect to v, then lastly you differentiate v with respect to x, and you will get dy upon dx. Clear? Understand? So this is how you can extend if your function of composite function. Clear? Understand? So now your question, if your function sin y equals sine of cos x, okay, or sine, you can say y equals sine of cos x. Okay, so how to find dy upon dx? Everyone do it. Okay, you have y equals sine of cos x, so find dy upon dx. Everyone do it. Very simple. Just here, this is actually extended form of chain rule. Okay, clear? So find what is dy upon dx for y equals sine of cos x. What is dy upon dx? You have y equals sine of cos x. Okay, everyone do it and give your answer. Very simple. Just you have to use here extended form of chain rule. Okay, so you have y equals sine of cos x. Okay, so first you differentiate y y with respect to sine of cos x. Okay, then you differentiate sine of cos x with respect to cos x, and then lastly you differentiate cos x with respect to x. Okay, and then you get the answer. Clear? Understand? Now moving to the next. Here if we will see another method. Okay, so if given function cannot be expressed in the form y equals f of x. Okay, if your given function cannot be expressed in the form y equals f of x, this form is called explicit function. Okay, so if your function cannot be expressed in this form, then how can you differentiate that function? So first you have to express that function in the form f of x comma y equals 0. Okay, so the function, given function, it cannot be expressed in the form y equals f of x, but it can be expressed in the form f of x comma y equals 0. Clear? Then to find derivatives of each term of f of x comma y equals 0 with respect to x. Okay, so you have the equation f of x comma y equals 0. This type of equation is implicit equation. Okay, and for finding the derivative, you have to first derivative you have to derivative with respect to x of each term of f of x comma y equals 0. Okay, now I am giving you an example. Suppose you have the f of x comma y function is sin x plus cos y. Okay, or sin x plus cos y. Okay, so now differentiate f of x comma y equals 0, that means sin x plus cos y equals 0. How to differentiate, and what will be the dy upon dx for sin x plus cos y equals 0? Everyone do it. How to differentiate sin x plus cos y equals 0? Everyone do it and give your answer. If we have the function that can be expressed in the form f of x comma y equals 0, then you have to differentiate each term of the equation f of x comma y equals 0 with respect to x. Clear? So you have to use this method, and then you can get the value of dy upon dx. Clear? Now move to the next. So if y is the product or the quotient of a number of complicated functions, okay, or if it is the form of f of x to the power g of x. Okay, this is actually function of x to the power function of x. Okay, so if your function like this, then what you will do? So if the y is the product of the product or the quotient of a function of complicated function, and it, or if it is of the form f of x to the power g of x, then the derivative of y can be found by first taking log on both sides. Okay, so if your function like this, f of x to the power g of x, f of x to the power g of x, then first you have to take log on both sides. Okay, and then differentiate it, then you will get the dy upon dx. Clear? So if your function y is equal to f of x to the power g of x, then you first have to take log on both sides, and then you have to differentiate. Clear? Understand? So when your function y is equal to f of x to the power g of x, then what you do first? You take log on both sides. Okay, so it implies log y is equal to g of x times log of f of x. Now differentiate with respect to x. So if we differentiate with respect to x, then 1 by y times dy upon dx, this is equal to g of x upon f of x times f prime of x plus log of f of x times g prime of x. Okay, so here in right hand side we use product rule to differentiate it by x. Okay, so here we first fix here g of x, but differentiate log of f of x. So g of x times differentiate of log of x is f of x by f prime of x. Okay, and then plus log of f of x times g prime of x, and here 1 by y dy upon dx, this is equal to this expression. Clear? Now simplify it. So before going next topic, I am giving you an example of the form f of x to the power g of x. Okay, suppose you have the function y equals x to the power x. So how to find dy upon dx? Everyone do it. You have y equals x to the power x and find dy upon dx. Everyone do it and give your answer in chat section. You have y equals x to the power x. So first you have to take log on both sides. Okay, and then differentiate it. So you have y equals x to the power x. So if you take log on both sides, then what you will get? You will get log y is equal to x times log x. Okay, and then simply differentiate and you will get the answer dy upon dx. Understand? Okay, I hope you will understand. Clear? So now if your function like x equals phi of t and y equals psi of t, where t is parameter, okay, so you have x and y in the parametric form. That means if your x is in the x is basically function of t and y equals function of t. Okay, so if x equals phi of t and y equals psi of t, where t is parameter, then how to find dy upon dx? How to find? Do you have any idea? So if x equals phi t and y equals psi t, then what is dy upon dx? So for doing this, first you have to differentiate x with respect to t, that is dx upon dt. Okay, so dx upon dt, this is equal to phi dash of t, and then differentiate y with respect to t. So dy upon dt, this is equal to psi dash of t. Clear? So now find dy upon dx. So dy upon dx can be write as dy by dt divided by dx by dt. Okay, so dy by dt is psi dash of t and dx by dt is phi dash of t. So dy upon dx is equal to dy by dt upon dx by dt. Clear? Understand? How to find when you have x equals phi of t and y equals psi of t? For that, first you have to differentiate x with respect to t and you have to differentiate y with respect to t. Then dy upon dx, this is equal to dy by dt upon dx by dt. Okay, by using this you can differentiate parametric function like this: x equals phi of t and y equals psi of t. Okay, and this rule is called parametric differentiation rule. So now, for example, if we take x equals sin t and y equals cos t, then what will be the dy upon dx? You have x equals sin t and y equals cos t. So what will be the dy upon dx? Everyone write in chat section. What will be dy upon dx for x equals sin t and y equals cos t? Apply here this rule. This rule, that is parametric differentiation rule. So everyone do it. What is dy upon dx for x equals sin t and y equals cos t? Everyone do it and give your answer. What is dy upon dx? X equals sin t, y equals cos t. So what you do? First you differentiate x with respect to t, that is dx upon dt, and that is d upon dt of sin t. Okay, and you will know dy upon dt of sin t is cos t. Okay, and you have y equals cos t. So dy upon dt, this is equal to d upon dt of cos t. Okay, and you will know d upon dt of cos t is minus sin t. Okay, now then find dy upon dx by dy upon dt divided by dx by dt. Okay, you will get the answer dy upon dx. Clear? Understand? Okay, I hope you understand. Now moving to the next. Now we'll see differentiation using substitution. Okay, sometime we face difficulty when our expression is very complicated. Okay, so if your expression complicated, that you can substitute, okay, by using some function like sin theta, cos theta, tan theta, sec theta, like this. Okay, so in order to find differential coefficients of complicated expression, some substitutions are very useful. Okay, so which are listed here. So here you can see in table, if we have the complicated expression like square root of a square minus x square. Okay, so if you have square root of a square minus x square, then what you have to substitute? That case you can substitute x equals a sin theta or x equals a cos theta. Okay, so remember here, if you have this type of expression, then substitute x equals a sin theta or x equals a cos theta. Clear? If you have the expression like this, square root of x square minus a square, then substitute here x equals a sec theta or x equals a cosec theta. Okay, why? Because if you substitute for first one x equals a sin theta, then you can write the expression square root of a square minus x square is equal to square root of a square minus a square sin square theta. Okay, and you can take common out a square from within the square root of. So square root of a square times 1 minus sin square theta, and you will know sin square theta plus cos square theta is 1. So from there you will get 1 minus sin square theta is cos square theta, and you can write this expression as square root of a square times cos square theta. Okay, and after removing square root you will get a cos theta. So this is how you can simplify this type of expression by substituting x equals a sin theta or x equals a cos theta. Clear? Understand? Now see, if you have the expression like square root of x square minus a square, then just you have to substitute x equals a sec theta or a cosec theta. Okay, how you can see, if we substitute x equals a sec theta, then this expression you will get square root of a square sec square theta minus a square. Okay, this is equal to square root of a square times sec square theta minus 1, and this is equal to square root of a square times sec square theta minus 1, and you will know sec square theta minus tan square theta is 1. Okay, so sec square theta minus 1 is tan square theta. So you will get square root of a square tan square theta equal to a tan theta. Okay, this is how you can simplify, and then you can find differentiation of that particular function. Clear? If you have the expression like square root of x square plus a square, then just you have to substitute x equals a tan theta or x equals a cot theta. Okay, how? If we substitute x equals a tan theta in this expression, then you will get square root of x square x square plus a square is equal to square root of a square tan square theta plus a square. Okay, this is equal to square root of a square times tan square theta plus 1, and you will know tan square theta plus 1 is sec square theta. Okay, so square root of a square tan square sec square theta equals a sec theta. This is how you can simplify and you can differentiate. Then see, if you have the complicated expression like this, square root of a plus x upon a minus x, or you have square root of a minus x upon a plus x, then you can substitute x equals a cos theta. Okay, and here you can see the formula 1 plus cos 2 theta is cos 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. Okay, use this formula and then you can simplify. If you have expression like square root of a square plus x square upon a square minus x square, or square root of a square minus x square upon a square plus x square, then substitute x equals a cos theta or x equals a sin theta. Why? Because you can see here a square plus a square cos square theta upon a square minus a square cos square theta. Okay, now using some important formulas of trigonometry functions, and you will get you can do simplification, and you will get the simplified form of this expression. Okay, and then if we have the expression square root of x by a plus x, then you can substitute x equals a tan square theta. Clear? If you have the expression square root of x minus a times x minus b, then substitute x equals a sec square theta minus b tan square theta. Okay, so if you have the expression ax minus x square, then substitute x equals a tan square and a sin square theta. If you have the expression square root of x by a minus x, then substitute x equals a sin square theta. If you have the expression square root of x minus a times b minus x, then substitute x equals a cos square theta plus b sin square theta. Okay, so you should remember the substitution. When you substitute x equals a sin theta or x equals cos theta, or x equals a sec theta or x equals a cosec theta, or x equal a tan theta or x equal to a cot theta, and etc. Okay, that you have to remember. Okay, and you can simplify this type of complicated expression by substitution. Clear? So this is very important. By using substitution, you can easily differentiate of any complicated function. So you should remember this formula, this substitution, very important, very useful. Okay, this will help you to solve very difficult question 1 differentiation. Okay, now moving to the next. Now we will see second order derivative. So as I told you, what is first order derivative? So when you have the curve y equals f of x, so then dy upon dx equals f prime of x. This is actually first order derivative. Okay, again if we differentiate dy upon dx with respect to x, then we get d upon dx of dy upon dx. This is second order derivative. Okay, so now we are going to learn second order derivative. So if your function y equals f of x, then d upon dx of dy upon dx, this is called the second order derivative of y with respect to x. Okay, and it is denoted by d2i upon dx2 or f double prime of x or y double prime or y2. Okay, so this is how we define second order derivative. So second order derivative means differentiation of the dy upon dx with respect to x again. Okay, and it is denoted by d2y upon dx2 or f double prime of x or y double prime or y2. Now see here an example. So in this example we will find second order derivative of function f of x equals x cube. So you have the function f of x equals x cube. Now find second order derivative of f of x equals x cube. Everyone find it. What is second order derivative of f of x equals x cube? And write your answer in chat section. What is f of x equals x cube? You have f of x equals x cube. So first you find first order derivative, okay, and then you again differentiate that first order derivative with respect to x, then you will get the second order derivative of f of x equals x cube. So let's see how to find second order derivative of f of x equals x cube. So first find first derivative. So f prime of x, this is equal to d upon dx of x cube, and you all know the formula d upon dx of x to the power n is equal to n times x to the power n minus 1. So apply this rule, okay, and find d upon dx of x cube. So d upon dx of x cube is equal to 3 times x square. Okay, so f prime of x equals 3 times x square. Now find second derivative. So for that you have to differentiate f prime of x with respect to x. Clear? So now differentiate f prime of x with respect to x, then you get the second order derivative f double prime of x. This is equal to d upon dx of 3x square. Okay, and d upon dx of 3x square, this is equal to 6 times x. So 6 times x is the second order derivative of the function f of x equals x cube. Now your task, suppose you have the function f of x equals sin square x. Okay, so find second order derivative of the function f of x equals sin square x. Everyone find it. What is the second order derivative of f of x equals sin square x? Everyone do it and give your answer in chat section. What is the derivative of f of x equals sin square x? What is the derivative of sin square x? Second order derivative. Here I am asking you find the second order derivative of f of x equals sin square x. Everyone do it and give your answer in chat section. Take your time and give you which of what is the answer for the second order derivative of f of x equals sin square x. So for finding first order derivative of f of x equals sin square x, you have to find derivative of sin square x, okay, with respect to x. So how to find? So the derivative of sin square x with respect to x, 2 sin x times cos x, okay, and you know 2 sin x cos x is sin 2x. Okay, now easily you can differentiate sin 2x with respect to x again. Okay, then you will get the second order derivative. So everyone do it. What is the second order derivative of f of x equals sin square x? Very simple. You can easily find f of x second order derivative of f of x equals sin square x. Very easy and simple. Do it and write in chat section. The function f of x is sin square x, and you have to find second order derivative of sin square x. So I hope you all can do it. Okay, good. Now we will discuss differentiation of a determinant. Okay, so how to find differentiation of a determinant? So if you have the determinant like y equals determinant p q r u v w l m n. Okay, so if you have y equals determinant p q r u v w l m n, and here you should note p q r u v w and l m n all are function of x. Okay, all are function of x. Now find dy upon dx. So everyone do it. So dy upon dx, this is simply equals determinant of dp by dx, dq upon dx, dr by dx, then uvw lmn, then plus determinant of pqr, du upon dx, dv by dx, dw by dx, then lmn, then plus determinant of pqr, uvw, dl upon dx, dm upon dx, dn upon dx. What we have done here? So for finding the differentiation of determinant y equals pqr uvw lmn. So first here we differentiate first row, okay, the element of the first row, and we get this determinant dp upon dx, dq upon dx, dr by dx. Okay, other elements are remain same. Okay, uvw lmn. Then in second row we differentiate second row in second determinant. So plus pqr du upon dx, dv by dx, dw by dx, then lmn. Okay, and we take here addition, then determinant of pqr, uvw, dl upon dx, dm upon dx, then dn upon dx. Okay, one by one we differentiate first row in first determinant, then in second row we differentiate second row, then in third determinant we differentiate the element of the third row. Okay, this is how we find the differentiation of our determinant. Clear? Understand? I hope you will understand. Very simple. So you should note this point. Okay, if you have the function like determinant y equals determinant pqr uvw lmn, then the differentiation is like this. Okay, and here you should note pqr uvw and lmn are function of x. So if you one of them are constant, then that differentiation will be 0. Clear? Understand? So wait a moment. We will now discuss some practice questions. So wait for a moment. So students, now we will discuss some practice question 1, differentiation. So let's look at question number 1. In question number 1, you have the function f of x is equal to modulus of cos x, and then you have to find f prime of 3 pi by 4. You have given here 4 options, so you have to choose the correct answer from the given options. So first of all, try it yourself and give your answer in chat section. Which option is correct? Everyone do it. So using here modulus concept, okay, modulus function concept. Just check here in which interval the function cos x is negative and in which interval the function cos x is positive. Okay, and this is how find the correct answer from the given options. So everyone do it and give your answer. Do it. Everyone do it. Which option? Very simple. Just you have to calculate by using modulus function concept. Everyone do it. Try it. Take your time and try it. Very simple. I hope you got your answer. So now let's check which option is correct here. Correct answer is option A. So you first match your answer with the correct answer. Now let's solve this question step by step. So you have the function f of x is equal to mod of cos x. So you can express f of x as cos x when 0 less than equal to x less than equal to pi by 2, and f of x is equal to minus cos x when pi by 2 less than equal to x less than equal to pi. Okay, so you should remember here, when 0 less than equal to x less than equal to pi by 2, then f of x is equal to mod of cos x is cos x. Okay, positive cos x. When pi by 2 less than equal to x less than equal to pi, then mod of cos x is simply minus cos x. Clear? So f of x is equal to cos x when 0 less than equal to x less than equal to pi by 2, and this is equal to minus cos x when pi by 2 less than equal to x less than equal to pi. Okay, so this concept enough for solving this question. Okay, now here, which value you take for the function f of x? You have to find a prime of 3 pi by 4, and now check in which interval 3 pi by 4 lie. In which interval 3 pi by 4 lies here? Here you can see 3 pi by 4. This value lies in the interval pi by 2 less than equal to x less than equal to pi. Okay, that's why we take here the function f of x is equal to minus cos x. Clear? Understand why we take here f of x is equal to minus cos x? Because here we have to find a prime of 3 pi by 4, and the 3 pi by 4, this value lies in the interval pi by 2 less than equal to x less than equal to pi. Okay, clear? Now find differentiation of f of x. So a prime of x is equal to plus sin x. So you all know differentiation of cos x is minus sin x, and already you have the sign negative sign. Okay, so a prime of x, this is equal to minus of minus sin x, this is plus sin x. Clear? Understand? Then find now a prime of 3 pi by 4. So now a prime of 3 pi by 4, this is equal to sine of 3 pi by 4. Sine of 3 pi by 4. So what is the value of sine of 3 pi by 4? So sine of 3 pi by 4 can be write as sine of pi minus pi by 4. Okay, and this can be written as sine pi by 4. Why? Because you know sine of pi minus theta is cos theta. Sorry, sine theta, not cos theta. Okay, so you should focus here. Sine of pi minus theta is sine theta. Clear? So sine of pi minus pi by 4 is sine pi by 4, and you all know the value of sine of pi by 4 is 1 by root 2. Okay, so a prime of 3 pi by 4 is 1 by root 2. Clear? Understand why we take the value? Why we take the value of f of x is minus cos x? You all understand? Here 3 pi by 4 lies between pi by 2 to pi. Okay, that's we take here minus cos x. Okay, then simply we differentiate and put the value of x equals 3 pi by 4, and we got the answer 1 by root 2. Understand? I hope you will understand. Now moving to the next. Now let's look at question number 2. In this question, you have the function f of x is equal to mod of x minus 1. Okay, and you have g of x is equal to f of x. Then for x is greater than 2, what is g prime of x? So we have to find here g prime of x is equal to what? You have given here 4 options, so you have to find the correct answer from the given options. So everyone do it. Try it yourself first. Which option is correct here? Give your answer in chat section. Everyone do it. Please do it. Very simple. Just you have to use your composite function concept. Okay. Everyone do it. Find g prime of x. Very simple. Easy and simple. Try it. Do it. Are you trying? Everyone do it. Please, everyone do it. I am waiting here to get your answer. Everyone do it and give your answer. I hope you got your answer. So now let's check which option is correct. The correct answer is here option A. Okay. Now let's solve this question step by step. So you first find f of x. You have the function f of x is equal to mod of x minus 1. Okay. And you first have to find f of x. So here mod of x minus 1 you have, and x is greater than 2. So at x is greater than 2, mod of x minus 1 simply x minus 1. Okay. So f of x is simply f of x minus 1, and f of x minus 1 is equal to modulus of x minus 1 minus 1. This is equal to mod of x minus 2. Clear? Then find g of x. G of x is equal to f of x, and you have f of x is mod of x minus 2, and for x is greater than 2, f of x is equal to mod of x minus 2 is simply x minus 2. Okay. So now f of x, this is equal to f of x minus 2. Now find f of x minus 2. So f of x minus 2 is simply equal to modulus of x minus 2 minus 1. Okay. And this is equal to mod of x minus 3. Clear? So g of x is equal to mod of x minus 3. Now split g of x function. For x is greater than equal to 3, this is x minus 3. When x is greater than equal to 2 but less than 3, then minus x plus 3. Clear? And now differentiate g of x with respect to x. So g prime of x is equal to 1 if x is greater than equal to 3. This is equal to minus 1 if 2 less than equal to x. Clear? Hence g prime of x is equal to minus 1 if 2 less than equal to x. Clear? So the value of g prime of x is equal to minus 1 if 2 less than equal to x. So I hope you will understand and it's clear to all of you. Is it clear to all of you? I hope you will understand. So now let's move to the next question. In this question, you have to find the derivative of y equals 1 minus x times 2 minus x times dot 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 n minus x at point x equals 1. So everyone find the derivative of y at x equals 1 and write your answer. Which option is correct from the given 4 options? So everyone do it. Try it yourself and give your answer in chat section. Everyone do it. Very simple. You can easily find it. Very simple. Do it. So keep in your mind here at x equals 1, you have to find the derivative of y. Okay. So find which option is correct. Very simple question. You can do it. Take your time and do it. Try it. Do it. Which option? Choose your answer. Everyone do it. I hope you got your answer. So now let's check which option is correct. The correct answer is here option B. Now let's start the solution step by step. So we have to find the derivative of y is equal to 1 minus x times 2 minus x times dot 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 n minus x at x equals 1. Okay, that means we have to find y prime. So here we can use the product rule to find the derivative of y with respect to x. So when you have a product of several factors, okay, that case what do you do? So the derivative is the sum of the terms where each term is the product of all the factors except one. Okay, 1 times the derivative of the exploded factor. So you should keep in mind this concept. So now evaluate at x equals 1. So now substitute x equals 1 into each term here, then you will get for 1 minus x when x equals 1 it becomes 0. For 2 minus x when x equals 1 it becomes 1. For k minus x when x is 1 it becomes k minus 1. Now the derivative involves calculating here y prime equals summation from I equals 1 to n of product of all terms except 1 times minus 1. Okay, this is the derivative of y, that is y prime. Okay, so you should note this note this y prime equals summation from I equals 1 to n of product of all terms except 1 times minus 1. Clear? Then find now dy upon dx. So here use product rule to find dy upon dx. So dy upon dx equals minus of 2 minus x times 3 minus x times dot 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 n minus x plus 1 minus x times 3 minus x times dot 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 n minus x plus dot 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 plus 1 minus x times 2 minus x times dot 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 n minus 1 minus x. Okay. Now because the product includes the term 1 minus x here, so which becomes 0 at x equals 1, and the result simplifies significantly as dy upon dx at x equals 1 is simply minus of n minus 1 factorial plus 0 dot 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 plus 0. Okay, and this is simply minus 1 times n minus 1 factorial, and this is our final answer. So this is the derivative of y equals to 1 minus x times 2 minus x times dot 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 dot, dot n minus x at x equals 1. Clear? Understand? Do you have any doubt? I think you understand. So now moving to the next. In this question, you have the function f of x is equal to x to the power n. Then then find the value of f of 1 minus f prime of 1 by 1 factorial plus f double prime of 1 by 2 factorial minus f triple prime of 1 by 3 factorial plus dot 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 plus minus 1 to the power n times f to the power 1 of 1 divided by f to the power n of 1 divided n factorial. Okay, so everyone try it and give your answer. You have 4 options. Choose the correct answer from the given options. So everyone do it. Take your time and do it. Which option is correct here? Please try it. Everyone do it. Very simple. Take your time and do it. Are you trying? Do it and choose your answer. Give your answer in chat section. Everyone. Very simple. You can do it. Everyone do it. Everyone do it and give your answer. Which option? I hope you got your answer. So now let's check which option is correct here. Correct answer is option B. Now let's solve this question step by step. So we have the function f of x is equal to x to the power n. Okay, this is given to us. Now find f of 1. So f of 1 is simply equal to 1. Okay, and this is equivalent to nc0. Okay, you can verify it. Then f prime of 1 by 1 factorial, this is equal to 1 n by 1 factorial. This is simply equals to nc1. Okay. Then f double prime of 1 by 2 factorial, this is equal to n times n minus 1 by 2 factorial. This is equal to nc2. You can verify it. Then f triple prime, if the triple prime of 1 of 3 factorial divided by 3 factorial equals n times n minus 1 times n minus 2 by 3 factorial. This is equal to nc3, and it goes like this, dot dot dot. Okay, so the now f to the power n of 1 by n factorial, this is equal to n by n factorial is equal to ncn. Okay, so this is how you found f of 1, f prime of 1 of by 1 factorial, f double prime of 1 by 2 factorial. You found f triple prime of 1 by 3 factorial and f to the power n of 1 by n factorial. Okay, now f of 1 minus f prime of 1 by 1 factorial plus f double prime of 1 by 2 factorial minus f triple prime of 1 by 3 factorial plus dot 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 plus minus 1 to the power n times f to the power n of 1 by n factorial. What is the value of this? So we found f of 1 is nc0, so this is nc0, so f prime of 1 by 1 factorial is nc1, so nc0 minus nc1, then plus nc2 minus nc3 plus dot 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 plus minus 1 to the power n times ncn. Okay, now from the binomial theorem, you know the expansion of x plus a whole to the power n. So what is the expansion of x plus a by x plus a whole to the power n? So x plus a whole to the power n, this is equal to summation from r equals 1 to n of ncn x to the power n minus r times a to the power r. Okay, so note this, the expansion of x plus a whole to the power n. So now we are going to using this expansion. Clear? Now here put x equals minus 1 and a equals 1. Okay, then you will get summation from r equals 1 to n of ncr of minus 1 to the power n minus r times 1 to the power r. Okay, this is equal to minus 1 plus 1 to whole to the power n. Okay, and this summation actually nc0 minus nc1 plus nc2 minus nc3 plus dot 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 plus minus 1 to the power n ncn. Okay, this is actually what we have to find, the expression f of 1 minus f prime of 1 by 1 factorial plus f double prime of 1 by 2 factorial minus dot 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 plus minus 1 to the power n f to the power n of 1 by n factorial. Okay, so we got here this is equal to 0. Clear? Understand? All you understand how we obtain the value of f of 1 minus f prime of 1 by 1 factorial plus f double prime of 1 by 2 factorial minus f triple prime of 1 by 3 factorial plus dot dot plus minus 1 to the power n f to the power n of 1 by n factorial is 0. Understand? Clear? Is it clear to all of you? Do you have any doubt? I think you have no doubt. We discuss here every step. Do you have any doubt in any step? Very simple. So I hope you will understand. Now moving to the next. In this question, you have the function f of x is equal to x square minus x upon x square plus 2x. Okay, here x is not equal to 0 and minus 2. Why? Because at x equals 0 and at x equals minus 2, this function is not defined. Okay, that's why we define here x is not equal to 0 and minus 2. Then we have to find d upon dx of f inverse of x. What does mean it? We have to find differentiation of inverse of function f of x with respect to x. Okay, so for doing this, first you have to find differentiation of f of x with first you have to find inverse of f of x, then you can find differentiation of f inverse of x. Okay, so you have given 4 options, so choose the correct answer from the given options. Which option is correct here? Do it everyone and give your answer. Everyone do it and give your answer. First simplify f of x and find f inverse of x, then differentiate. Very simple. You can do it. Easily doable. Choose your answer. Everyone, choose your answer. Try it. Everyone try it and choose your answer. Very simple. Do it and give your answer. Are you trying? I hope you got your answer. So now let's check which option is correct here. Correct answer is option B. Okay. So first you should match your answer with correct answer. Then see the solution step by step. Let's solve this question step by step. So first let y equals x square minus x upon x square plus 2x. Okay. So now take x common in numerator and also in denominator. Then what you will get? Y equals x times x minus 1 divided by x times x plus 2. And here x will be cancelled to each other. Then this is equal to x minus 1 divided by x plus 2. So you now got y equals x minus 1 divided by x plus 2. So now easily you can find f inverse of x. How you can find y f inverse of x? So just you have to multiply, cross multiplying. Okay, here the equation y equals x minus 1 by x plus 2. So now find the inverse here. So y equals x minus 1 divided by x plus 2. And now cross multiplying, you will get yx plus 2y is equal to x minus 1. Okay, now arrange this equation. So it implies x times y minus 1, this is equal to minus 1 minus 2y. Okay, now you have to write actually x in terms of y. So how can we write? So x is equal to 2y plus 1 divided by minus y plus 1. Okay, and here x is not equal to 0 and minus 2. So we got here x equals 2y plus 1 divided by minus y plus 1. So what is the f inverse of x? What is the f inverse of x? You have here x equals 2y plus 1 divided by minus y plus 1. So now find f inverse of x. Everyone find? So f inverse x is simply 2x plus 1 divided by minus x plus 1. Okay, now you have to differentiate f inverse of x with respect to x. So now differentiate. Therefore d upon dx of f inverse of x, this is equal to minus x plus 1 times 2 minus 2x plus 1 times minus 1 divided by minus x plus 1 whole squared. Okay, how we found here, we using here quotient rule to find the differentiation of f inverse of x. Here the numerator we have 2x plus 1 and denominator we have minus x plus 1. So first here we fix denominator minus x plus 1 but differentiate numerator 2x plus 1. Okay, then we get 2. Then minus we fix 2x plus 1 but differentiate denominator minus x plus 1, that is minus 1. Okay, and we divided whole thing by minus x plus 1 whole squared and we got the differentiation of f inverse of x. Now simplify it and you will get 3 upon minus x plus 1 whole squared. Okay, so d upon dx of f inverse of x, this is equal to 3 upon minus x plus 1 whole squared, and this is our final answer. Understand? All you understand? Do you have any doubt? Very simple. I think you will understand. Now moving to the next. In this question you have the function f of x is equal to 2 plus mod of x minus mod of x minus 1 minus mod of x plus 1. Then what you have to do? Then you have to find f prime of minus 1 by 2 plus f prime of 1 by 2 plus f prime of 3 by 2 plus f prime of 5 by 2. Okay, what is the value of this expression? That you have to find. So you have given 4 options. So which option is correct here? Everyone try it yourself first and give your answer. Which option is correct? Everyone do it. Everyone try it. Please do it and give your answer. Very simple question. You can do it. Everyone do it and give your answer. Do it everyone and choose your answer. Which option is correct? Take your time and do it. Very simple question. Everyone, give your answer. Are you trying? Try it one your one first and choose your answer. Which option? Right? Give your answer. Try it. You are learning, so don't worry to give wrong answer. Okay, so everyone give your answer. Everyone do it and give your answer. So I hope you got your answer. So now let's see how to solve this question. The correct answer is option D. Now let's solve this question step by step. So here now focus one solution. So we have f of x is equal to 2 plus mod x minus of mod of x minus 1 minus of mod of x plus 1. Okay. Now you have to find f prime of x. So f prime of x is equal to d upon dx of 2 plus mod x minus of mod of x minus 1 minus of mod of x plus 1. Okay, and this can be written as d upon dx of mod of x minus d by dx of mod of x minus 1 minus d upon dx of mod of x plus 1. Okay, so what is the differentiation of mod of x? Can you say what is the differentiation of mod of x? So for doing differentiation of d upon dx of mod x, that means to find d upon dx of mod x, so you have to use piecewise function. Mod of x is equal to x when x is greater than 0, mod of x is equal to minus x when x is less than 0. Okay, similarly find you write first mod of x minus 1 when it is x minus 1 when it is minus x plus 1. Okay, when x is greater than 1, then mod of x minus 1 is x minus 1. When x is less than 1, then mod of x minus 1 is minus x plus 1. Okay, and similarly mod of x plus 1 is x plus 1 when x is greater than minus 1, and mod of x plus 1 is minus x minus 1 when x is less than minus 1. Clear? So you should have to this concept, and then you have to find derivative of this function. So now find the derivative of each function. So d upon dx of mod x is basically signum function of x, and you will know signum function of x, this is equal to minus 1 when x is less than 0, and this is equal to 1 when x is greater than 0, and here signum function of x is basically d upon dx of mod x. Clear? Then d upon dx of mod of x minus 1 is basically signum function of x minus 1, and signum function of x minus 1 is defined as minus 1 when x is less than 1 and is equal to 1 when x is greater than 1. Clear? Then signum function of x plus 1 is equal to minus 1 if x is less than minus 1, and this is equal to 1 when x is greater than minus 1. Okay, we found here all the derivative. Now f prime of x, this is equal to signum function of x minus signum function of x minus 1 minus signum function of x plus 1. Clear? Now calculate the signs at points. So here x, when x equals minus 1 by 2, so x equals minus 1 by 2 is negative number. So what will be the value of f prime of minus 1 by 2? So f prime of minus 1 by 2 is simply equals to minus 1. You can directly find. Okay, you can also find like this: minus 1 minus of minus 1 minus 1. Okay, this is equal to minus 1. Why? Because x equals minus 1 by 2 is negative, and we have learned signum function x is minus 1 when x is less than 0. Then f prime of 1 by 2. So 1 by 2 is positive. Okay, so here x is greater than 0. So f prime of 1 by 2 is simply equal to 1. Okay, simply equal to 1. Why? Because x equals 1 by 2 is positive, and you know signum function of x, that is actually differentiation of mod of x. This is equal to 1 when x is greater than 0. Then see f prime of 3 by 2. F prime of 3 by 2. Here 3 by 2 is greater 3 by 2 is greater than 0 and greater than 1. Okay, this is 1.5. So what will be the value of f prime of 3 by 2? So this is actually 1 minus of 1 minus 1. This is equal to minus 1. Clear? Then find f prime of 5 by 2. 5 by 2 is greater than 1 and greater than 2. So f prime of 5 by 2 is equal to 1 minus of minus 1 minus 2 minus 1. This is equal to minus 1. So f prime of minus 1 by 2 plus f prime of 1 by 2 plus f prime of 3 by 2 plus f prime of 5 by 2. This is equal to minus 1 plus 1 minus 1 plus minus of minus 1. Okay, and if you simplify, then you'll get minus 2. So the value of the expression f prime of minus 1 by 2 plus f prime of 1 by 2 plus f prime of 3 by 2 plus f prime of 5 by 2 is equal to minus 2. Clear? Understand? I hope you all understand. Do you have any doubt? So if you have any doubt, then you can ask. Do you have any doubt? All things are clear? Do you have any doubt? Hello students? Do you have any doubt? Okay. So that's all for today's lecture. Thank you for your attention. I hope this lesson was helpful to all of you. So stay tuned for physics class. Hello students, welcome to today's lecture. In today's lecture, we are going to learn about thermal properties of matter and thermodynamics. And this is theory part first. Okay. This is our disclaimer. So firstly, we will see a trend analysis of the chapter in JEE main examination. So if we talk about the overall weightage of the chapter thermal properties of matter, so we can say 2.4%. If we talk about yearly quotient distribution, so we can say in 2023 question asked from measurement of temperature, number of questions 1, and their difficulty level question was average. In 2022 question asked from thermal expansion, uh, number of questions 1 and question was average. Okay. Similarly, in 2021 question asked from thermal expansion, number of questions 1 and their difficulty level average. In 2020 question again asked from thermal expansion and number of questions 1, and if we talk about difficulty level, so we can say question was easy. All right everyone. So are you ready for the today's lecture? So in today's lecture we will cover first uh, heat, then we will discuss temperature. After that we will study thermometer, then we will study temperature scales, then thermometry. After that we will study thermal expansion, then thermal expansion of solids. After that thermal expansion of liquids, then we will study anomalous or exceptional behavior of water, then thermal expansion of gases, then we will discuss specific heat capacity. After that molar heat capacity, then water equivalent of a substance, then we will discuss calorimetry, then we will discuss change of state, then latent heat, then sublimation, and last we will study the heating curve. So these are the topics for today's lecture that we will discuss. So our first topic is heat. Now here the question arises, what is heat? Think about it. So let's discuss. Heat is a form of energy. Heat is an energy that characterizes the thermal state of matter. Okay, you know matter, everything that occupies space. It transfers from one body to another due to temperature difference. And if we talk about unit and dimension and quantity, so we can say heat is a scalar quantity and it is a form of energy. Therefore, its dimensions will also be the same as that of energy. Therefore, its dimension is ml square t raised to the power minus 2. Okay, its SI unit will also be the same as that of energy, which is joule, whereas its practical unit is calorie. Okay, and there is a relation between calorie and joule, and that relation is, we can say, 1 calorie, 1 calorie is equal to 4.18 joule. Okay, this is the conversion from calorie to joule. Okay. And the experimental unit also calorie. All right, this is very important. If mechanical energy is converted into heat, then the work done, which we denoted by capital W, and the heat produced, which is called Q, their ratio remains the same and constant. Okay, and if we understand this concept mathematically, then it means that work is being converted into heat. In this case, the ratio of work done W and heat produced Q always remains equal or constant. And if we denote that constant by J, then we get W equal to JQ. Here J is a constant which we call the mechanical equivalent of heat. Okay, the mechanical equivalent of heat is the amount of work that is required to produce 1 unit of heat, which shows that heat and mechanical work can be converted into each other's forms. Look at here. So if we understand heat with an example, you can see in the figure that a metal strip has been taken. This metal strip is held from one side and along its entire length. Okay, this one. So at some intervals, wax beads are attached. So when we place a candle at the free end, okay, at the free end of the metal strip, that end gains heat from the candle's flame. Okay, so heat flows from one end of metal strip to other end. Okay, why? Because it is a metal strip and heat always flows from a higher temperature to lower temperature. So as heat flows from one end to another end, you will observe that the wax beads will start to melt. Okay, so with this setup we can demonstrate the flow of heat. Okay, now we will discuss the next topic, temperature. Temperature, okay, so we can say that the temperature is a measure of average kinetic energy of the particles of a substance. That is, temperature is the measure of average kinetic energy of particles of any object. Simply we can say uh, that temperature indicates how cold or how hot any objects. That is, we determine the hotness or coldness of an object using temperature. So how is this determined? We can feel by touching whether an object is hot or cold. But to measure it, we use a thermometer. Okay. Temperature also affects the physical properties of matter. How? Think about it. Let's take an example. We can consider the color of a metal like iron. When we heat iron, it starts to become red in color, and at even higher temperatures it starts to appear yellow and also becomes soft. So we can say that due to temperature the physical properties of an object are affected. We can say that two or more objects are in thermal equilibrium. So when the temperature of those objects is same, meaning when thermal equilibrium exists, the temperature of the objects will be same. Okay everyone, clear? Any doubt here? And the SI unit of temperature is Kelvin. Okay, the next topic is thermometer. A thermometer is an instrument, alright, that is used to measure the temperature of any body. Some common types of thermometers are: first is the liquid mercury thermometer. Okay, so now let's look at the range of this liquid mercury thermometer. The range of a liquid mercury thermometer is from minus 50 degrees Celsius to 350 degrees Celsius. The second type of thermometer is a gas thermometer, in which nitrogen gas is used, and the range of this thermometer is minus 200 degrees Celsius to 1600 degrees Celsius. And third type of thermometer is pyrometers. Okay, and the range of this type of thermometer is minus 800 degrees Celsius to 6000 degrees Celsius. This means that there are three different types of thermometers: liquid thermometer, gas thermometer, and pyrometers. Yes, good, good, good. All right. So look at here. Uh, you also have a thermometer, laboratory thermometer, which is generally a mercury thermometer used to measure the temperature of any body or any liquid. Its diagram is also given. Look at here. This is a laboratory thermometer. All right. Now we will discuss about scales of temperature. So scales of temperature means that there are different ways to measure temperature. All right. We can measure temperature in degrees Celsius. We can also measure temperature in Fahrenheit. We can also measure temperature in Kelvin. Yes or no? So there are different scales through which we measure temperature. So these are called scales of temperature. The three most common temperature scales are Celsius scale or centigrade scale, Fahrenheit scale, and the third is Kelvin scale. Okay, Kelvin scale is also called the absolute scale. So these three are the most widely used temperature scales. There are other scales as well, but these three are the most common. Now we will look at the lower reference point and upper reference point and their unit for different scales of temperatures. Okay, so first is Celsius. So in Celsius, the lower reference point or ice point is 0 degree Celsius, and the upper reference point or steam point is 100 degrees Celsius. In the Celsius scale, the unit of temperature is 0 degree Celsius, and its unit symbol is this one, degree Celsius. Okay, this one. And if we talk about the second scale, that is Fahrenheit scale. So in Fahrenheit scale, the lower reference point is 32 and the upper reference point or steam point is 212. Clear? So in Fahrenheit scale, the unit of temperature is degree Fahrenheit. Similarly, uh, the third is Kelvin scale, and the upper reference point is uh, 373.15, and the unit of temperature is Kelvin, which is denoted by capital K. So these are the three temperature scales: Celsius, Fahrenheit, and Kelvin. Okay, everyone. There is a relation between these three scales. That is now uh, we we will look at the relation between Celsius, Fahrenheit, and Kelvin scales. So using this relation, we can easily convert the temperature measurements from one unit to another. And this relation is C by 5 is equal to F minus 32 divided by 9, which is equal to K minus 273.15 divided by 5. Okay. So in the first case, if the temperature is given in Fahrenheit scale, then we can convert it to the Celsius scale in this way. Degree Celsius is equal to 5 by 9 multiplied with degree Fahrenheit minus 32. This means if any temperature is given in F, then we subtract minus 32 from it and multiply it by 5 by 9 to find it in degree Celsius. Clear? Similarly, in the second case, we will convert temperature from the Celsius scale to Kelvin scale as follows. So Kelvin is equal to degree Celsius plus 273.15. If we are given a temperature in degree Celsius and we need to calculate it in Kelvin, then we will add 273.15 to degree Celsius value. That then that temperature will be marked in Kelvin. Okay. So here I have a one question for you. So question is if the temperature is 33 degree Fahrenheit, okay, 33 degree Fahrenheit, what will be the temperature in degree Celsius? Please give me the answer in the chat box. Yes. Yes. What will be the answer? To solve this question, you need to this formula. Okay, the question is if the temperature is 33 degree Fahrenheit, okay, 33 degree Fahrenheit, what will be the temperature in degree Celsius, value of temperature in degree Celsius? Clear? So to solve this question, you need to use this formula. Degree Celsius is equal to 5 by 9 into degree Fahrenheit minus 32. So just put the value of Fahrenheit minus 32 and multiply by 5 by 9. You will be get the answer in degree Celsius. Please solve. And if the temperature is given in Celsius scale, then we can convert it to Fahrenheit scale in the following way. So that is degree Fahrenheit is equal to 9 by 5 degree Celsius plus 32. This means if any temperature is given in degree Celsius and we need to calculate it in Fahrenheit, then we will multiply it by 9 by 5 and then add 32. Then we will get the temperature in degree Fahrenheit. Okay? Yes, your answer is good, VK. The next concept is thermometry. Basically, thermometry is a branch of physics that is used to measure temperature. Clear? Branch of physics that deals with the measurement of temperature is called thermometry. In other words, we can say when we use any method or instrument to measure temperature, that entire process is called thermometry. So it is just a branch of physics to use to measure the temperature. Now in thermometry, there are different types of temperature scales. The first is the Celsius scale. The second is the Kelvin scale. And third is the Fahrenheit scale, which we have discussed previously. Okay. So Kelvin, Celsius degree scale and Fahrenheit are all three important temperature scales. If we talk about specifically about the Celsius scale, or we can say Celsius degree scale, it has a lower reference point, which we also call the ice point, meaning uh, where water freezes. So that is the water freezing point. Look at here in this diagram. So 0 degree Celsius means water freezing point or lower reference point. Clear? And there is an upper reference point. This one, upper reference point, which is 100 degree Celsius, which we can also call the steam point or boiling point. And the Celsius scale is divided into a total of 100 parts from lower reference point to the upper reference point, meaning there are 100 equal parts from 0 to 100 degree Celsius. Clear? Normal body temperature is 37 degrees Celsius. Look at here, this one, as shown in the figure. So if we find the thermometric properties at 0 degrees Celsius, which we call the ice point, and 100 degrees Celsius, which we call the steam point, and an unknown temperature T degrees Celsius, then x0, x100 and xt are respectively the values of the thermal properties at 0 degrees Celsius, 100 degrees Celsius and unknown temperature T. Okay. So here we know thermometric property is the physical characteristics of a substance that changes with temperature, and we can measuring that change. So thus the values of thermometric properties at 0 degree Celsius, 100 degree Celsius and the some unknown temperature T as follows: xt minus x naught x0 divided by T is equal to x100 minus x0 divided by 100, or we can say xt minus x0 divided by x100 minus x0 is equal to T by 100. Okay. So we will rearrange the above given relation and find the unknown temperature according to this expression. So which is given as follows. So T equal to xt minus x0 divided by x100 minus x0 or multiply with 100 degrees Celsius. Okay. The next topic is thermal expansion of solids. Thermal expansion of solids means when we heat an object and it expands. This process is called thermal expansion. Almost all the substances such as solid, liquid, and gas expand upon heating and contract upon cooling. Okay, so the expansion of any substance upon heating is called thermal expansion. All right, and here we will study about three types of thermal expansion: linear, area, and volume. So firstly, we have a linear expansion. Any linear material or body, for example a rod, look at figure, this is a rod whose length is L naught. Okay, so L naught is the actual length of this object. Okay, and when we heat it, due to thermal expansion, its length increases slightly. So now the change or expansion that occurred linearly along only one dimension, therefore it is called linear expansion, and the change that has occurred will be called it delta L, as shown in the figure. So delta L means change in length. This means linear expansion occurs in a single dimension. All right. If a rod has a length L naught at temperature T, then when the temperature increases by delta T, the elongation in the rod's length is delta L, which is equal to L naught into alpha into delta T. Here delta T is the temperature rise, and the elongation in length or increase uh, increase can be calculated as delta L is equal to L naught into alpha into delta T. Okay, so by rearranging this equation we can solve for alpha. So alpha equal to delta L divided by L naught into delta T. Okay, here alpha is the coefficient of linear expansion whose value depends on the nature of the material. Whose value depends on what? Nature of the material. And if the nature of the material changes, then the value of alpha will also change. Okay, so now let's see how to calculate the final length. So for that there is a term LF which represents the final length. So LF is equal to L naught plus L naught alpha into delta T, that is original length plus change in length. So take L naught common, then 1 plus alpha into delta T remains. So LF equal to L naught into 1 plus delta T. Alright, clear? The next is uh, area expansion. So in linear expansion, we saw that expansion occurs only in one dimension. Yes or no? But in area expansion, when a solid object is thermally expanded, its expansion occurs in two dimensions. Clear? So the expansion of solid objects in two dimensions itself is called area expansion. If an object has length L and width B and it is thermally expanded, then both its length and width will expand. That is, if the object it is two dimension, then it will expand area wise. Okay, in this two we will follow similar steps to find the coefficient of area expansion as just as we did in the case of linear expansion. All right everyone, so in this case the coefficient of area expansion is denoted by beta. Beta is the coefficient of area expansion, which is equal to delta A divided by A naught into delta T. Just like a linear expansion, here delta A is change in area and A naught is our original area. Okay, so the final area AF will be A naught uh, into 1 plus beta into delta T. Here A naught is the area of the body at initial temperature T, and when there is a change of temperature, that is delta T, so the area also changes. So in this diagram, look at here, if we talk about the area at temperature T, at T temperature, then this denotes the initial area A naught. Okay, A naught, which is a shaded area in this diagram. Okay, shaded area is the initial area, and when we increase the temperature by delta T, okay, then the area also expands two dimensionally. All right, so this is what is called area expansion or thermal expansion in two dimensions. So the change in area, that is represented by delta A. Okay, so uh this this one is the change in area when we heated two dimensional shape of the body. All right, clear everyone? All right, now the third one is volume or cubical expansion. When any solid object's expansion occurs in three dimensions, it is called cubical expansion or volume expansion. Okay, if we talk about a cube uh, whose initial volume is V naught, and when the temperature increases some amount, let's say delta T, okay, then in that case its volume will change, that is delta V. So in this case the coefficient of volume or cubical expansion is denoted by gamma. So gamma is equal to delta V divided by V naught into delta T. That is gamma equals to here delta V divided by V naught into delta T. All right, where we have final volume Vf, which is given by this formula, Vf equal to V naught into 1 plus gamma into delta T, and V naught is the initial volume of the object. All right, at temperature T. When we can say that when the temperature is initially T and then volume is V naught. So note that different thermal coefficients alpha, beta and gamma are related to each other. Okay, this is very important concept. That is that is coefficients such as alpha in this case of linear expansion, beta in the area expansion and gamma in volume expansion. All these are related to each other, and the relation is alpha equal to gamma alpha equal to beta by 2 or alpha equal to gamma by 3. So we can say alpha equal to beta by 2 equal to gamma by 3. Okay, so this is very important relation. As temperature increases, clear, density decreases, and the relation that justifies this is rho equal to rho naught divided by 1 plus gamma into delta T. Here delta T means increase in temperature that we have caused, or we can also write it as rho equal to rho naught 1 minus gamma into delta T for valid for small temperature. Clear? So to get this formula, listen carefully. Here we have used binomial approximation. Okay, if a term is given in terms of 1 plus x whole power n, and x is less than 1, then according to binomial approximation we can write it in the form of 1 plus nx. So this is our case of volume or cubical expansion which shows 3-dimension expansion. Alright. So look at figure. Uh, in the figure it is clearly represented that the initial volume is V naught, which is represented by the shaded part. Okay, and delta V represents the volume expansion. So initial volume V naught after giving the temperature. After giving the temperature, we can say the dimension will change, and that change in volume denoted by delta V. Okay everyone, I think this is clear. Yes or no? Clear? The next is thermal expansion in liquids. So we know that a liquid neither expands linearly nor in terms of area, which means that liquids do not undergo linear or area expansion. Only volumetric expansion occurs. And for liquids, there are two coefficients of volume expansion. Okay, the first is we have the coefficient of apparent expansion gamma A. So we can say apparent expansion is the expansion of a liquid in which both the real expansion of the liquid and the expansion of the container in which it is placed are considered. After that, the net expansion of the liquid that we observe is called the apparent expansion of the liquid. So the formula for the coefficient of apparent expansion gamma A is as follows: gamma equal to apparent expansion in volume divided by initial volume into delta T. So we can write delta VA divided by V into delta T. Okay. The second is the coefficient of real expansion. The real expansion of a liquid is independent of the expansion of the container. Okay. So if we understand this from this diagram, here you have put liquid in the container. Okay, and heated it. You must have observed that when the temperature increases, okay, the liquid gradually starts to expand. Alright, when liquid expands, its volume starts to increase. Yes or no? So here we are considering the expansion of the container to be negligible. We have attached a small tube here and observed that the liquid's volume is increasing, and when we can also measure the amount of increase in volume. So gamma R, which is the coefficient of real expansion, is equal to real expansion in the volume divided by initial volume multiplied by delta T. Okay, and mathematically we can write delta VR divided by V into delta T. Okay, where T represents the change in temperature due to the temperature increases and volume of the liquid expanded. So when we giving the heat, the volume increases. Now we will discuss about the exceptional behavior of water. Okay, that is how water behaves differently from other liquids. Let's see. Water exhibits a different behavior. So when water is heated from 0 degree Celsius to 4 degree Celsius, look at here, 0 degree Celsius to 4 degree Celsius, it contracts, meaning its volume decreases. The volume of a given amount of water decreases when we cool it from room temperature until the temperature reaches 4 degrees Celsius. So at temperature above 4 degrees Celsius, water behaves normally like other liquids. If we look at this graphically, then on y-axis there is a volume, okay, and on x-axis there is temperature, okay. And if volume is increasing, then density will increase, and if density is increasing, the volume will decrease. So these are two inversely related, are inversely proportional, okay. So if we observe here that as temperature increases from 0 degree Celsius to 4 degree Celsius, then volume will decrease and density will increase, okay. So look at here in this graph. So when we increasing the temperature from 0 degree to 4 degree Celsius, so the volume is decreasing here, yes or no, and density is increasing. In second one, there is a density versus temperature graph. So temperature increasing, volume decreasing, but density increasing. This is between 0 to 4 degree Celsius, okay. This means the minimum volume of water will be 4 degrees Celsius, okay. So look what happened at 4 degrees Celsius. So volume became minimum and density became maximum. That's why it is said that water exhibits anomalous behavior or exceptional behavior. Alright. So when we can see in the graph that as temperature increases 0 to 4 degrees Celsius, the volume decreases and density increases. After 4 degrees Celsius, what will be the change? Think about it. So we can say after 4 degrees Celsius, water will expand like other liquids upon increasing the temperature. So look at here. After 4 degrees Celsius, the volume increasing, okay, but here density decreasing, okay. So water behave like a other liquids, and this anomalous behavior of water is very important for the existence of aquatic life in regions where the temperature is below 0 degrees Celsius. Okay everyone, clear? Yes or no? If you have any doubt, please ask. No doubt? All right. Next concept is thermal expansion of gases. So now uh, we know gases do not have any definite shape, therefore gases only undergo volume expansion. For this reason, gases always expand only volumetrically. Firstly, the coefficient of volume expansion at constant pressure is denoted by alpha, which is equal to delta V divided by V naught multiplied by 1 divided by delta T. That is alpha equal to delta V upon V naught into 1 divided by delta T. Okay. Here V is the change in volume and delta V naught is the delta V is the change in volume, V naught is the initial volume, and delta T is change in temperature. And final volume V prime is equal to V into 1 plus alpha into delta T. And the second is coefficient of pressure expansion at constant volume beta. So beta is equal to delta P divided by P into 1 divided by delta T. Here the final pressure will be P prime equal to P into 1 plus beta into delta T. Okay, so these are the formulas for thermal expansion of gases, which are very important from an exam point of view. Okay, the next topic is specific heat capacity. Specific heat capacity is a property of a substance that indicates how much the temperature of that substance will change when it absorbs or rejects a given amount of heat, provided that its phase is not changing. So regarding the definition, specific heat capacity is defined as the amount of heat per unit mass that is absorbed or rejected by a substance to change its temperature by 1 unit. So we write the specific heat capacity using the formula as follows: S is equal to Q upon M into delta T. Here S is the specific heat capacity, Q is the amount of heat that has been absorbed or rejected, and small m is the mass, and delta T is the temperature change. It means the amount of heat per unit mass that a substance absorbs or rejects, so it's that is that its temperature changes by 1 unit. So that is the specific heat capacity. This formula is very important. And SI unit of specific heat capacity is joule per kilogram per Kelvin. The value of specific heat capacity can be anything from 0 to infinity. Okay, in some substances, in a particular situations, its value can also be negative. So it depends on the situations. All right. And when we multiply the mass m of a body and its specific heat, it is called heat capacity. So heat capacity is C equal to m into S. Thus the heat capacity depends on the amount of substance. Okay, whereas specific heat does not depend on the amount of substance, it's a material property. Now here let's now see what molar heat capacity. So if we talk about the definition of molar heat capacity, then molar heat capacity is defined as the amount of heat required to raise the temperature of 1 unit mole of a substance by 1 degree Celsius. That is called molar heat capacity. Okay, mathematically we can write Cm equal to Q divided by mu into delta T. Cm is the molar heat capacity and mu represents the number of moles. Generally, for gases, 2 molar heat capacities are common. Think about it. You know, 2 molar heat capacities? Yes or no? Molar heat capacity at constant pressure, Cp, and second is molar heat capacity at constant volume, which is denoted by Cv. Alright. So the next topic is water equivalent of a substance. If we understand this definition, then the water equivalent of a body means how much mass of water will absorb or release the same amount of heat as that body does when its temperature changes by 1 degree Celsius. So suppose you are heating water, you took 250 gram water. Okay, you gave some heat to increase the temperature of that 250 gram water by 1 degree Celsius. So some amount of heat is absorbed by this water. If the same amount of heat is required by one substance of mass m to increase its temperature by 1 degree Celsius, then this 250 gram mass of water is the water equivalent of that substance. The formula for the water equivalent W is equal to ms. Okay, where W is the water equivalent, m is the mass of that substance, and s is the specific heat capacity of that substance. Okay, everyone. So now the topic we are going to discuss is calorimetry. Calorimetry means the measurement of heat. Okay, when a body at high temperature is brought into contact with another body at low temperature, then in that case the hot body loses as much heat as the cold body gains, provided no heat escapes into the surroundings. So in this case, the heat gained by the cold body is equal to the heat lost by the hot body. Okay, a calorimeter generally consists of a metallic vessel, so, and a stereo. Okay, this is stereo, which are made of same material such as copper or aluminium, as shown in the figure. This vessel is placed inside a wooden jacket which contains heat insulating uh, material such as glass wool. So this outer jacket, okay, uh, we can say equipped with insulating materials, acts as a heat shield and reduces the loss of heat from the inner vessel to the surroundings. Okay, so this is just for information. And we can say that a device in which the measurement of heat can be done is called calorimeter. Okay, and the device that measures the heat is called calorimeter. Clear? If the temperature of the substance in calorimeter changes, then the heat exchanged is given by Q equal to ms delta T. Here delta T is the change in temperature. If the temperature of the body increases, it means that the body has absorbed heat. Otherwise, heat has been released from the body. Okay, any doubt? The next topic is change of state. Okay, matter generally exists in three states: solid state, liquid state, and gaseous state. Yes, right. So when transition occurs from one state to another, it is called change of state. Okay, change of state means when matter changes from one state to another, such as from solid state to liquid state or liquid state to gas state. This process is called change of state. All right, so two common changes of state are solid to liquid, such as the melting of ice, and liquid to gas, such as water turning into steam. Okay, so this process can also be reversed, meaning it can be from gas to liquid or liquid to solid. All right, so how does liquid turns into gas? Think about it. So let's look at an example. When clothes are washed and dry, the water trapped in the clothes turns into steam upon receiving heat. Yes or no? So these changes occur when there is an exchange of heat between the substance and its surroundings. This means whenever heat exchange occurs, then this state of change happens. All right. Now let's understand with a diagram. So look at here. Here are the three states: solid state, liquid state, and gas state. When matter changes from solid state to liquid state, okay, it is called fusion. Yes or no? And when it returns from liquid state to solid state, known as solidification. Okay, for example, ice is solid. When it turns into water, that process is called fusion. This is the best example for understanding. Similarly, if a substance changes directly from solid state to gas state, it is called sublimation. And if it comes directly from gas to solid state, it is called deposition. Similarly, the change from liquid state to gas state is called vaporization. Liquid to gas, vaporization. Clear? And if we talk about an example, so we can say on rainy days, water accumulates on roads. Yes or no? Then in the sun, then water turns into steam through the vaporization process. And when the substance returns from gas state to liquid state, that process is called condensation. So there are a total 6 processes of change of state: fusion, solidification, vaporization, or condensation, sublimation, or deposition. Clear everyone? Yes or no? Now let's see latent heat. Whenever the state of a substance changes, the heat required at that time mainly depends on two things. One is the heat of transformation, and the second is the mass of the substance undergoing the state change. That is, whenever a state change occurs, the amount of required heat depends on the heat of transformation and mass. Okay, and if the mass of substance is m, all right, and if the mass of substance is m, so we can say it is changing from one state to another. Then the formula for the required heat, q equal to ml. With this formula we can calculate heat. Okay, clear? Where q is the required heat, m is the mass of the substance, and l is the latent heat. All right, if clear, write in the chat box everyone. L is referred to as latent heat, and it is a characteristics value for every substance. Okay, L equal to Q by M. Its SI unit is joule per kilogram. Okay, meaning SI unit, Q is joule, and SI unit of mass is kilogram, and so SI unit of become L, becomes joule per kilogram. All right. The amount of heat that is transferred per unit mass when the state of substance changes is called latent heat of that substance. This is the definition of latent heat for any process. That is, the amount of heat required per unit mass during a change state is called, is what is latent heat. Okay everyone? Good. So in the case of ice, the latent heat of fusion of ice is 80 kilocalorie per kg. Okay, this means that when ice converts into water, it converts from ice to water at 0 degree Celsius. Okay, and there is a no change in temperature during the change of state, as you can see. You can also see in the figure. Okay, this one, this parallel line parallel to x-axis, so that the no change in temperature, there is a phase change. So the energy required per unit mass for the ice convert into water without any temperature change is called latent heat of fusion. Clear? And in the case of water vaporization, meaning here water is converted into steam. In this case, latent heat of vaporization is 540 kilocalorie per kg. So in this figure, phase change is shown from the solid to liquid. Okay, this one, solid to liquid and liquid to gas. So when water converts into steam at 100 degrees Celsius, the energy required per unit mass without any temperature change is called latent heat of vaporization, as is also represented in the figure. Alright. So apart from the case of phase changes, if we provide heat to the substance, its temperature will also increase linearly. Okay, okay everyone, clear? The next topic is sublimation. Think about it. When a substance directly goes from solid state to vapor state, or we can say gaseous state, without passing through the liquid state, then this process is called sublimation, and that substance is said to be sublime. So give me some example of sublime. So we have one example for you, that is camphor. When camphor directly turns from solid to gas without becoming a liquid, then this process is called sublimation. Okay, clear everyone? All right. Now we will discuss a heating curve. So if we supply energy at a constant rate to a body that is in solid state and whose temperature is below its melting point, then the curve formed between temperature and time is called a heating curve. Okay, and this is a graphical representation between temperature and time only, as shown in the figure. Look at here, this is the heating curve, temperature versus time, and we will learn each one, A to B and B to C, C to D and D to E. Okay, so from here, O to A, first we will talk about O to A. OA represents heating of solid. Okay, now the specific heat capacity of the solid substance as solid will be inversely proportional to the slope of OA. Okay, now this AB represents the melting of the solid. So here a phase change occurs. All right, we have studied this before. So this means the solid X state exists only up to A, and at A the phase change occurs. So AB represents the melting of the solid. Therefore the length of AB in the graph is directly proportional to latent heat of fusion LF. Alright, here length of AB represents how much heat or how much time was required to completely melt a solid substance. Here BC represents the heating of the substance in its liquid state or liquid form. Now the specific heat capacity as liquid is of the substance in the liquid will form inversely proportional to slope of BC. Okay, and now this is CD. Okay, so CD represents the boiling or vaporization of substances liquid form. So here a phase change occurs. So this means the liquid state exists only up to C, and at C a phase change occurs. Therefore, the length of CD in the graph is directly proportional to latent heat of vaporization LV. Alright. Here the length of DE represents how much heat or how much time was taken to completely um, we can say uh, vaporize a substance in a liquid form. Okay, so DE represents the heating of the substance in its gaseous form. So now the specific heat capacity S gas of the substance in gaseous form will be inversely proportional to slope of D. Okay everyone, clear? Any doubt? Yes or no? Any doubt here? All right. Thank you for your attention. Now we will solve some practice questions based on these topics. So are you ready for the practice questions? Yes or no? Everyone, mark your attendance first. Are you ready? Hello everyone. Now we will solve some practice questions that is based on thermal properties of matter and thermodynamics. This is practice question part 1. Okay, so I think, are you ready for the practice questions? This is our disclaimer. So here we will solve some practice questions based on thermal properties of matter and thermodynamics. The first question is an aluminium sphere of 20 centimeter diameter. Okay, 20 centimeter diameter is heated from 0 degree Celsius to 100 degree Celsius. Okay, uh, its volume changes by what? So in this question, an aluminium sphere is given with a diameter 20 centimeter and it is heated from 0 degree Celsius to 100 degree Celsius. The question asks for the change in the volume for aluminium due to this temperature change. Okay, So here the linear expansion of coefficient of aluminium, which indicates how much an object's length increases with temperature, is given. Its value is alpha Al, that is 23 into 10 raised to the power minus 6 per degree Celsius. So which option is correct? Option A, 28.9 cc. Option B, 2.89 cc. Option C, 9.28 cc. And option D, 49.8 cc. So which one is correct? Uh, Please try to solve this question, everyone, and find out the correct option. You have some time. After that, we will provide the solution of this question. So the correct option is option A. Okay, let's solve this question. In this question, we need to find the volume expansion of an aluminum sphere. Alright, so when temperature increases, the volume of any solid also increases. To calculate the volume expansion, we use the formula for cubical expansion. Delta V equal to gamma into V into delta T. Here delta V is the change in volume, gamma is the volume expansion coefficient, V is the original volume, and delta T is the temperature difference. Okay, so we take the volume expansion coefficient gamma as 3 times the linear expansion coefficient alpha. This relation exists between the coefficient of linear and volume expansion, that is gamma equal to 3 times alpha. Therefore, the formula for the volume expansion becomes 3 alpha into V into delta T. Okay. Now for aluminium, alpha equal to 23 into 10 raised to the power minus 6 per degree Celsius is given. And the radius of this sphere is r equal to d by 2, which is equal to 10 centimeter. So its volume V equal to 4 by 3 pi r cube. So just put the value of r, you will be get 4 by 3 pi cube means r cube means 10 cube. Now substituting all values into the formula, you will be get delta V is equal to 3 into 23 into 10 raised to the power minus 6 into 4 by 3 pi 10 cube into 100. Okay. So from this calculation, when we solve this calculation, so from this calculation, we get the change in volume, which is approximately 28.9 cubic centimeter. Okay, this means when the aluminium sphere is heated from 0 degree Celsius to 100 degree Celsius, its volume increases by approximately 28.9 cubic centimeter. Okay, okay everyone, clear? Next question, Cp and Cv are specific heats at constant pressure and constant volume respectively. It is observed that Cp minus Cv equal to A. For hydrogen gas, Cp minus Cv equal to B for nitrogen gas. Okay. The correct relation between A and B is what? So the question asks what the correct relation will be for the differences A and B for hydrogen gas and nitrogen gas. That is, what is the relation between A and B? Okay, so the correct relation needs to be chosen from the given options. There are four options. Option A is A equal to B. Option B is A equal to 14 into B. Option C A equal to 28 into B, and option D equal to 1 divided by 14 into B. So which option is correct? Please try to solve this question and please solve. After that we will provide the solution of this question. Okay everyone? So I expect you are solving. Please solve. Yeah, Karthik, VK, Varsha, please solve this question. Anyone? Which one is correct? Okay. So the correct option is B. Okay, let's solve it. So specific heat capacities are Cp at constant pressure and Cv at constant volume. Okay, so Meier's relation for these two is given as Cp minus Cv equal to R by M, and here R is a gas constant, M is the molar mass of the gas. Alright, as given in the question, for hydrogen gas H2, Meyer relation is Cp minus Cv equal to R by 2 equal to A. Okay, because the molar mass of hydrogen gas is 2. Okay, and for nitrogen gas, Meyer's relation is Cp minus Cv equal to R by 28, which is equal to B. And let this is equation second. Okay, why 28? Because the molar mass of nitrogen gas is 28. Okay, now from these two equations we find that the relation between A and B. So A equal to R by 2 and B equal to R by 28. So the relation between A and B is A equal to 14 into B. Okay, this means that the difference in Cp minus Cv for hydrogen gas is 14 times greater compared to nitrogen gas. Okay everyone, so B option is correct. All right, next question. A copper ball of mass 100 gram is at a temperature T. It is dropped in a copper calorimeter of mass 100 gram filled with 170 gram of water at room temperature. Subsequently, the temperature of the system is found to be 75 degrees Celsius. T is what? So in this question we need to find the initial temperature T of the ball. Okay, given that specific heat capacity of copper is 0.1 calorie per gram degree Celsius. So there are four options. Option A 885 degrees Celsius, option B 1250 degrees Celsius, option C 825 degrees Celsius, and option D 800 degrees Celsius. Okay, so which one is the correct, or we can say which one is the initial temperature T of the ball? Alright everyone, so please try to solve this question. After that we will provide the solution of this question. You have some time, please solve. So here you have to find out the initial temperature T of the ball. Alright, yes, I think are you solving? Please solve. Which one is correct? A, B, C or D? So the correct option is A. Okay. Uh, let's see. Let's solve this question. In this problem, we are using the principle of heat transfer. Okay, which is also known as energy conservation. When a hot copper ball, which is at an initial temperature T, is dropped into a copper calorimeter that also contains water, heat exchange occurs. Okay, so the copper ball loses its heat, and that heat is gained by both the water and the calorimeter, causing their temperature to rise. Given are the masses. The mass of the copper ball is 100 gram. The mass of calorimeter is 100 gram, and the mass of water is 170 gram. Room temperature, that is the initial temperature of the water and calorimeter is 30 degrees Celsius. The final temperature of the system becomes 75 degrees Celsius. Initial temperature of the copper ball is T degrees Celsius. Alright. And the specific heat capacity of copper and water also given. For copper it is 0.1 calorie per gram degree Celsius, and for water the specific heat capacity is 1 calorie per gram degree Celsius. Alright. So according to principle of calorimetry, for a closed system, heat gained is equal to the heat lost. So the heat gained is calculated for both the water and the calorimeter combined, and heat loss occurs only from the copper ball because it is at a high temperature. Alright. So the heat gained by the water will be mw sw into delta T, because we write heat as Q equal to ms delta T. Alright. And the heat gain of the calorimeter will be m calorimetry s copper in calorimeter into delta T, and heat lost by the copper ball will be Mb into S copper into delta T. Okay, into delta T. So final equation will be Ms SW delta T plus S calorie S copper delta T is equal to Mb S copper delta T. All right. So we will substitute the values into the formula. Okay. So the temperature of both the water and the calorimeter increased from 30 degrees Celsius to 75 degrees Celsius. So their temperature change was 45 degrees Celsius. So the heat gained by the water will be 170 into 1 into 45, and that of the calorimeter will be 100 into 0.1 into 45. So the heat lost by the copper ball will be 100 into 0.1 into T minus 75, because the ball cooled from its initial temperature T to a final temperature of 75 degrees Celsius. The heat gained and the heat lost should be equal. Therefore, the equation will be this one. Okay, this one. So when we solving this temperature, you will be get the value of T. So solving this equation, we get T equal to 885 degrees Celsius, which was the initial temperature of the copper ball. Thus, we found the initial temperature using the basic principle of heat transfer. All right, everyone, clear? Yes or no? Any doubt? Okay. The next question. 100 gram of water is heated from 30 degrees Celsius to 50 degrees Celsius. Ignoring the slight expansion of the water, the change in its state's internal energy is what? So in this question, 100 grams of water is given, alright, which is being heated from 30 degrees Celsius to 50 degrees Celsius. We need to find the change in internal energy of water, and here we are asked to ignore the slight expansion of water, meaning the change in volume should not be considered. The specific heat capacity of water is given as 4184 joule per kilo kg Kelvin. So this question basically asks what is the change in internal energy when the temperature of water increases from 30 degrees Celsius to 50 degrees Celsius. So the given options: option A 8.4 kilojoule, option B 84 kilojoule, option C 2.1 kilojoule, and option D 4.2 kilojoule. So which one is correct? Think about it and please try to solve this question. So the correct option is option A. Okay. So in this problem, uh, the mass of water is given as 100 grams, but the specific heat capacity is given is 4184 joule per kilogram Kelvin. So the units of specific heat capacity are based on kilograms. Therefore, it is necessary for us to convert the mass of water from grams to kilogram. Okay. So conversion is as follows: m equal to 100 gram. So it is equal to 100 divided by 1000 kg. So it will be 0.1 kilogram. As It is also stored in the it is also stated in the question that the volume change of water is very small. Therefore, we can ignore the work done, meaning the work done will be considered zero, because work done is generally W equal to P into delta V. So if the volume change is negligible, then the work done will also negligible or zero. Okay. Therefore, the change in the internal energy of water will be solely due to the heat transfer, and its formula is delta U equal to Q equal to M into C into delta T. All right. Here m is the mass of the water in kilograms, c is the specific heat capacity, which for water is 4184 joule per kilogram Kelvin. Delta T is the change in temperature, which is 50 minus 30 equal to 20 degrees Celsius. Now we substitute these values into the formula, or we get delta U. Alright, so this is just mathematical calculations. So when you do this calculation, you will be get 8.4 kilojoule. Okay, this means that the internal energy of the water increased by 8.4 kilojoules when its temperature increased from 30 degrees Celsius to 50 degrees Celsius. Okay, everyone. One last question. Question is in this question we have a PV indicator diagram which shows the behavior of an ideal gas. In a PV diagram, the relation between pressure and volume V is shown. Okay, you have to determine by looking at the diagram which of the given options shows the relation between temperature pressure graph for the same process. Meaning TP diagram is which one is correct here? Given options A, B, C, D. So which one is correct? Please try to solve this question. This is a very simple question, and this is the last question of the today's lecture. Okay. So the correct option is C. Alright. So in this question, we have a graph which represents a isothermal process. Isothermal means temperature remains constant, that is T equal to constant. Now in this process there is a relation between pressure P and volume V, and that is PV equal to constant because T is constant. Alright. This means if volume increases, then pressure decreases, and if volume decreases, then pressure increases. It is given in the question that P1 is greater than P2. Alright, that is the initial pressure P1 is greater than final pressure P2. If we look at the graph, then the graph of an isothermal process is P versus V. Alright, is a hyperbola. But if the graph becomes P versus T, becomes pressure and pressure versus temperature. So then due to temperature being constant, the graph of pressure will be a horizontal line because temperature is not changing. Okay. So therefore, if P1 is greater than P2 and temperature is constant, then the graph will be a straight line parallel to the pressure axis, horizontal line. Okay. So option C is correct. Alright, everyone. So this is the last question of the today's lecture. I hope this is clear. Yes or no? Clear? Thank you for your attention. In next lecture, we will solve more questions. Alright? Thank you.